Okay. So today's topic, permutation and combinations. Do you have any idea about what is meant by permutation? Anyone? Any idea? So permutation is nothing but an arrangement or listing of objects in which the order is important, or simply you can say that selection and arrangement. Selection and arrangement. Okay. Permutation is nothing but selection and arrangement. Okay. For example, we want to arrange A, B, C in any order. Okay. How many ways you can arrange these three words, three letters? In how many ways you can arrange these three letters? How many number of ways? A, B, C. Okay. Actually, A, B, C or A, C, B, like that. How many ways you can arrange these three letters? Anyone? See, we are arranging, right? First, we will select. We have three chairs, three people, like that. So, three chairs, three people. Okay. We need to arrange them. So, in how many ways? Yes, finished. Good. Good. No, good. Perfect. So, nothing but three letters, three chairs, right? Three letters, three chairs, or three places. Nothing but 3 factorial. Okay. 3 factorial, nothing but 3 into 2 into 1. Total 6 ways. Okay. A, B, C, A, C, B. Then if you take B, C, A, B, A, C. You take C, A, B, B, A. So total 6 ways. Right. So nothing like 3 letters. To arrange 3 letters, we have 3 factorial ways. So how many number of ways you can arrange cost? In how many number of ways you can arrange the word cost with or without meaning? In how many number of ways the word cost can be arranged? Any idea? Yes, good. Nothing but we have 4 letters, right? 1, 2, 3, 4. To arrange 4 letters, 4 factorial. Number of ways is 4 factorial. So 4 into 3 into 2 into 1. 24 ways. Okay. Clear. So permutation is an arrangement. Okay, the listing of objects or number of elements set of arranged in sequence. Okay, for example, you can take a 0, 0, okay, 987. Okay, 987. You need to form a 2-digit number using these 3 digits. Okay, how many 2-digit numbers can be formed by using 987? How many 2-digit numbers can be formed by using 987? Any idea? Any idea about? Okay, in the first place, how many possible arrangements are there? We have 7, 8, 9. Okay, we have 3 numbers. We are going to form only 2-digit number. In the first place, how many possible is there? Out of 7, 8, 9, for how many numbers they have possible to arrange this place? Out of 7, 8, 9, okay, in the first place, what number can be filled? Okay, either you can have 7 or 8 or 9, right? Out of 3, anyone. So we have 3 ways, right? Similarly, for second place, okay. So first place, we have 3 possible, either 7, 8 or 9, 3 ways. If repetition is not allowed, then what is the answer here? If repetition is not allowed, So after filling one number, for example, if I place 8 in the first place, okay, then the second place was filled by either 7 or 9. So we have only 2 ways, right? So we need a 2-digit number. So first place and second place. So into. So total you have 6 ways. So for this topic as well as for probability, and means into, or means plus. Okay, for probability as well as for permutation combination, and representation is into or plus. Is it clear? Okay, to arrange 3 letters or 4 letters. So clear, but so basic formula NPR is permutation. Okay, n number of items are number of items taken at a time. So n factorial by n minus r factorial. Okay. So what is the value of 7p3? So what is the value of 7p3? 7p3. Okay. So without using the formula, you can find the values. Listen carefully here. 7p3. From 7, 3 numbers. Reverse. From 7, 3 numbers reverse. So 7 into 6 into 5. That's all. The answer is 210. Yes. So clear. 7p3. Okay, you can apply formula using factorial, or else you can write like this. 7p3. From 7, 3 numbers reverse. So 7, 6, 5. Multiplied. Okay, we have only 3 here, right? R is 3. We are taking 3 items at a time. So from 7 in is number of items. In that I need only 3. That's why we are taking only 3 terms. From 7, 3 terms. Reverse. Okay, 7 into 6 into 5. If you use formula also, you will get the same value. To clear this page. 1 minute. For example, if you apply the formula, so NPR formula is n factorial by n minus r factorial. N is here 7, right? By n minus r factorial. 7 minus 3 factorial. So 7 factorial by 4 factorial. 7 factorial nothing but 7 into 6 into 5 into 4 into 3 into 2 into 1 by 4 factorial. So 4 into 3 into 2 into 1. You cancel it, you will get only 7 into 6 into 5. So instead of applying the formula, you can directly find the value. 7p3. From 7, 3 numbers. Here we have only 3, right? From 7, 3 numbers reverse. So 210. Is it clear? Is it clear about how to find the value of permutation? Okay. 3p3. What is the value of 3p3? 3 chairs, 3 persons. We need to arrange it. 3 chairs, 3 people. It's nothing but 3 factorial. Okay. Or else you can say as I did. 3 from 3 numbers reverse. 3, 2, 1. You have 6. Yes, Sanju. Good. Yes, Ash. So clear. It's nothing but NPN equal to n factorial. Okay, we have 3 letters, we have 3 places. Okay, the answer is n factorial. NPN equal to n factorial. NP naught. NP naught is nothing but 1. We didn't select anything. If we select, we need to arrange it, right? So we didn't select anything. So the answer is only 1, like window shopping. Okay. So NP naught equal to 1. And NP1 equal to n. N ways. NP1 equal to n. These are the basic formulas. Right? NPR, the formula is n factorial by n minus r factorial. Okay. NPN is 3 n factorial. NP0 is 1. NP1 is n. Suppose we have 5 pens. Okay. We need 1. So how many ways we can arrange them? We have 5 pens. You need to select 1. Okay. If you select 1, there's no need of arrangement, right? So 5p1. So 5 ways. You write all the pen, right? Clear. So 5p naught. 5p naught answer is 1. We didn't select anything. The answer will be 1. Is it clear? These are basic formulas. We're going to apply in the questions book. Is it clear? Any doubts? The basic formula, NPR formula. I need more responses, sir. So basic formula is NPR is n factorial by n minus r factorial. To find the value without using the formula, just start the number from n up to the r items, number of terms. Okay. So what is the value of 10p2? 10p2. From 10, two numbers reverse, right? So 10 into 9. That's all. 90. Yes, good. Okay. Then how many ways you can arrange the word string with or without meaning? In how many ways you can arrange the word string with or without meaning? How many ways? And how many ways can arrange the word string with or without meaning? How many letters are there? 5, right? So 5 factorial. Okay, 5 letters. Each are different, right? So 5 factorial. So 5 into 4 into 3 into 2 into 1. The answer will be 120. At least up to 9 factorial, you must know the value. From 1 factorial till 9 factorial. Okay, minimum. Okay. Is it clear? String. Okay. So from is you will give the option. Another question. Yes. For example, in the string, okay, how many 3-letter word? Okay, how many 3-letter word can be formed from the string? How many 3-letter word with or without meaning can be formed from string? Okay, we have only 3 places, but we have 5 letters, right? Okay, so we are going to form a 3-letter word from string with or without meaning. Now, how many ways you can form? Yes, most of them are getting the right answer. Good. So then we can say like this: 5p3. We have 5, right? Someone is marking here. Okay. So we have 5 letters. Out of 5 letters, we need only 3. Okay. First, we will select 3. Then we will arrange it. Something but permutation, right? Selection and arrangement. Out of 5, we are going to select 3. Then we are going to arrange it, right? So permutation. So 5p3. From 5, 3 numbers reverse. 5, 4, 3. The answer is 60. Or else, in the first place, okay, the first place, swing, okay, out of 5, which letter is possible? Out of 5 letters, which one is possible to place in the first one? All the 5, right? So we have 5 ways. Similarly, in second place, how many possibles are there? 1 over, right? So we are remaining 4. So 4 ways. The third place, here 3. So if you include all the 3, you will get the 3-letter word, right? You cannot say or. We have to include first and second and third place. 60. Is it clear? So if you have arrangement, the word arrangement or order, then the question is permutation. How many number of ways, okay, can arrange? How many arrangements? If you have a word like arrangement, okay, then the question is permutation. In a question, if we have only selection, okay, then it is combination. Is it clear? Permutation nothing but both selection and arrangement. Both selection and arrangement. It is permutation. Both selection and arrangement. But in combination, we have only selection. a shopping, like a shopping, right? So clear, Ruba? Permutation, nothing but both selection, arrangement. Order is important. Okay, order is important here. But in selection, combination, order is not important. Only we are selecting, right? So order is not important, but in permutation, order is important. The arrangement. So clear? Is it clear for first format? Suppose the same question, we need to form a 3-letter word. Repetition is allowed. Okay, in the word swing. Okay, in the word swing, we need to form a 3-letter word, but repetition is allowed. In how many ways you can? In how many ways you can arrange the word? Repetition is allowed. So we have 3 places, right? The first place, we have 5 letters. So all the 5 are possible. So 5. Second place, again, repetition is allowed, right? Again, we have same 5 number of letters. Again, third place, we have 5. So nothing but 5 cube. 125. Yes. 125 ways. 125 times or 125 ways. So from one, actually we have 125 ways. The repetition is allowed. Okay. Generally, you will take like this. Repetition is not allowed. Okay, usually. The question, if they mention repetition is allowed, then you can go for this format. Okay. Most of the questions you will have this type of 5 into 4 into 3 like that. Is it clear? Is it clear? Now, multi-set, nothing but the word will repeat again. We have a similar word. For example, so what are the number of ways to arrange the word cost? What are the number of ways to arrange the word cost? 24, right? 4 factorial, 24. Okay, good. What are the number of, how many number of ways you can arrange the word apple? This is a multi-set. We have a same word, right? We have a same word repeated. So first count the number of letters. So 1, 2, 3, 4, 5. Okay. So write 5 factorial. So we are going to arrange all the letters. So write 5 factorial. Divide by P 2 times repeated, right? Similar. So divide by 2 factorial. Is it clear? So we are, this is a multi-set. Multi-set, permutation of multi-set. If some number of objects have same kind or similar, then we have to divide by that. So answer is 5 factorial, nothing but 120 divided by 2. Right? You will get 60 ways. Is it clear? Is it clear? Okay. We have same letter repeated. Then, for example, what are the number of ways to arrange the word reader? How many number of ways you can arrange the word reader? Here this is a multi-set. The letters are repeating once again, right? R repeated 2 times, E repeated 2 times. So what will the answer? Just in terms of factorial, we need to find the exact value. Yes, Charan, good. So we should not write 4 factorial, Charan. Okay. But listen carefully. We have 6 letters, right? So 1, 2, 3, 4, 5, 6. So write 6 factorial. Divide by R repeated 2 times. So you have to write individually. So R 2 times, then E 2 times. So 2 factorial to 2 factorial is different from 4 factorial, right? 4 factorial value is 24, but 2 factorial and 2 factorial is only 4. So you have to write like this. So 6 factorial divided by 2 factorial into 2 factorial. This is for letter R, and this is for A, for E. So clear? Any doubts, man, in arrangement? Multi-set or different letters? Okay, what are the number of ways in arranging the word Malayalam? In how many number of ways you can arrange the word Malayalam? These are the examples for multi-set. Give a try. Yes, good challenge. Any other? So Malayalam, just count the letters, number of letters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9 factorial. Divide by m repeated 2 times, right? So 2 factorial. A repeated for 4 times. So into 4 factorial. Then L 2 times. That's all. Is it clear? So no need to find the exact value, but just write as it is in terms of factorial. Is it clear? Okay. So permutation nothing but selection and arrangement. Order of selection is important or doesn't matters. Okay. Okay, the reader will be 180 ways. Good. 720 divided by 2 into 2, 4. You will get 180. The option if you have in terms of factorial, just leave as it is. Or in terms of numbers, then you have to find the value of factorial. No issues, ma. Is it clear? So if you have a, okay, last one, give a try for corporation. Try to arrange the word corporation. In how many number of ways you can arrange the word corporation? Corporation, how many ways you can arrange the word corporation? Okay. So just count the letters here. Here you have 11 letters, right? So 11 factorial. Yes, Charan, good. 11 factorial. Then, if you go for O will be for 3 times, right? So 3 factorial. Then R 2 times. So 2 factorial. That's all. So clear? Yes, good. Yes, Hemant. Yes, Meera, good. So clear how to arrange the words. Shall we move to the next one? Numbers. Yes, Aishwarya. You want me to repeat it again? Okay. Suppose if you want to arrange the word cost, okay, we have 4 distinct letters, 4 different letters, right? So answer is 4 factorial. In corporation, we have total count is 1, 2, 3, 4, or else you go for Apple. 1, 2, 3, 4, 5. We have 5 letters, right? So 5 factorial. In that, P repeated 2 times. So divide by 2 factorial. We have a same letter, right? So 2 times. Divide by 2 factorial. Since similarly for corporation, we have total 11 letters. So write as it is, 11 factorial. Then divide by O repeated 2 times. 3 times. 3 factorial. Then R 2 times. R 2 factorial. Remaining letter of 1 times, right? Is it clear? Done. No. So these are the basic concepts we are going to learn. Repetition allowed and non-repetitions allowed. Okay, always together, never together, odd and even places, no together. In numbers, we are going to learn 0 and without 0. Okay, for example, we have 1, 2, 3, 4, 5. We have 5 digits. We want to make a 3-digit number using this 5 digits. Using these 5 digits, form a 3-digit number. In how many ways can you form a 3-digit number? You need to form a 3-digit number. In how many ways you can form a 3-digit number using 1, 2, 3, 4, 5? Yes, you can go for 5P3. This is arrangement, right? We are going to select 3 numbers out of 5. Then we are going to arrange it. The selection and arrangement. So answer is permutation, right? You can say that 5p3, 5 into 4 into 3, 60. Or first place out of 5, any one maker. So 5 ways. Second place out of 4, right? Already we have written one number. Out of 4, anyone. Last 3. The answer also again 5 into 4 into 3. You will get 60 here. Okay, this is without 0, non-zero. Suppose if we have 0. Okay, if we have 0. How many 2-digit numbers can be formed using the digits 0, 1, 2, 3? Okay, this is actually numbers. We have 2 cases above. One is without 0 and including 0. Now we have 4 digits. Out of 4 digits, you need to form a 2-digit number. Okay, in how many ways we can form? Okay, in first place, how many possibles are there? In first place, no, 4 cannot be the answer, right? 0 cannot be the first place. 0 cannot be in the first place, right? If we apply 0 here, then it becomes a single digit number. Okay, so 0 cannot be in the first place. So remaining 3, anyone. So we have 3 ways. Okay, now the second place, again 3. Out of 3, you will write any one number, right? 1, 2, 3. Instead of 1, 2, 3, I will write any one number. For example, if I take 2 here, remaining now second place 0 maker 30, for example. 30 is a 2-digit number. Okay, so 0 will not be in the first place. Okay, so remaining 3, anyone will occur here. Then second place 0 maker. So 1, 2, 3. Again 3 ways. The answer is 9 ways. Okay. Now, once again, I will give an example. You already have seen this. Okay. Okay, so listen. So we have 1, 2, 3, 4, 5. Okay, we have 1, 2, 3, 4, 5. Yes, Charan, 3 ways is not equivalent to 3 factorial. Okay, so here we have 1, 2, 3, 4, 5. We're going to form a 3-digit number. We're going to form a 3-digit number. Okay, listen. Okay, this is first one without 0, non-zero numbers. Okay, 1, 2, 3, 4, 5. We're going to form a 3-digit number out of 5. Now, how many ways you can find them, arrange them? So just draw 3 places. In the first place, okay, anyone out of 5, anyone will occur. So we have 5 ways. The second place, anyone occur, right? So out of 5, 1 is seated here. For example, I mark 3 here. In this place, out of 4, anyone will occur. So 4 ways. For example, if I take 2 here, okay. The third place, remaining 3, anyone will occur. So answer will be 5 into 4 into 3. The answer is 60. Or else you can say that 5p3. Okay, 5p3, 5 into 4 into 3. We have 5 numbers. Out of 5, we need only 3-digit number, right? So 5p3. So we have 60 ways. Suppose if you have 0, for example, 0, 1, 2, 3, we need to form a 2-digit number. So we want to form a 2-digit number, okay? In the first place, 0 will occur or not? In the first place, 0 will occur or not? To form a 2-digit number, can write 0 in the first place or not? No, right? So 0 not possible here. So remaining 3, out of 3, anyone will occur. So we have 3 ways. So clear? We have 3 ways. Okay. Then the second place, we have already written one number here. Instead of, for example, I have written 2 here. Okay, 2 for example. Then the second place, now 0 may occur. Okay, so now we have 3 numbers 0, 1, 3. Out of 3, anyone will come here. So 3 ways. So total answer is 9 ways. Is it clear? Should not write like this. Out of 4, okay, out of 4, should not write P2, 4 P2. This is wrong. Since 0, here we have a 0, right? So should not write like, if you write like this, 0, 4 P2 can take any 2 numbers and we can arrange it. That's the meaning here. But 0 is one of the digit. So we cannot write like this. Is it clear? Okay, if 0 occur, just draw a line here, number of places, and fill each place. The first place, 0 will not be a digit, right? If you write 0 here, you will get only a single digit number, 0, 4. Suppose if you write 4, 0, then it is a 40, double digit number. The first place, 0 will not occur. Is it clear? Any doubts for numbers? Any doubts? We have some problems but to do. Okay, so okay, next concept. Okay, next concept. I want to take a screenshot of it now. So next concept, for example, Xerox. Okay, we take Xerox. How many number of ways you can arrange the word? Okay, Xerox. In that, vowels always comes together. Okay, vowels always together. In how many number of ways can arrange the word Xerox? Okay, condition, vowels always together. So listen carefully. So how many vowels are there here? So what are the vowels here in the word Xerox? E and O, right? So take inside the box. The question is vowels always together, right? So write the vowels inside the box and remaining letters here. Okay, clear? Or else you can write like this. For first, I will find for read. Okay, for read. Here, vowels always comes together. In this case, write E, A inside the box and write the remaining letters here. Okay. Now we need to arrange these letters, words, right? So 1, 2, consider this box as 1. Since they comes together, so can arrange any one of them. The remaining will sit nearby them, right? So take this box as 1 person. So we have R, D, and this one. Total 3. So to arrange 3 letters, we have 3 factorial ways. And inside the box, we have EA. You can see it like this, EA or AE. So we have 2 ways, right? So to arrange 2 letters, we have 2 factorial. Is it clear? So take the vowels inside the box, consider them as 1, a single person. Okay. So here 1, 2, and this one is 3. Total 3 persons. So to arrange 3 letters, 3 factorial. And inside the box, we have 2 letters, right? So 2 factorial. The answer is 6 into 2, 12 number of ways. So clear? Similarly, if you go for Xerox, we have E and O as a vowel. Okay, so put it in the box. Now we have 1, 2, 3, and this has 1, right? Total 4. 1, 2, 3, and this is 1, 4. So 4 letters, 4 factorial. But in that 4 letters, X repeated 2 times. So divide by 2 factorial. Is it clear? Here R, D, and this one are different. That's why I written 3 factorial. But here 1, 2, 3, and 4. So 4 factorial, but X repeated twice. So divide by 2 factorial into, again we have 2 factorial, right? 2 letters. To arrange 2 letters, we have 2 factorial. So if you get strike, the original answer will be 4 factorial. The answer is 24. Is it clear? Suppose the question is asked like that. Vowels always comes together. Is it clear, Bang? Okay, vowels always comes together. So then you can take EO as a single term. Okay. Can you try for corporation? Condition, vowels always together. Give a try. In corporation, vowels always together. Give a try. Arrange the word corporation in such a way that vowels always comes together. Anyone? Okay. Vashni, if letters are repeated, then you have to write divide by some number of letters, right? I think here so you will get some other way. Okay, Charan. Okay. Charan, you should not write 11 factorial. The question is vowels always together, right? Okay, so listen carefully here. I will give an example of corporation here. Yes, Kanaga, good. Corporation. Listen carefully. So vowels always together. So write inside the box. O. Actually, you have to write all the letters. If your number repeated 3 times, you have to write the same 0, 0, 0, then R, R. Right? So clear? Okay. Then the remaining letters C, R, sorry. The vowels right. So I will write A and I here. The vowels always together. So I will write vowels here. Okay. Take them as one. It's a single person. Okay. The remaining we have C, R, P, R, T, and N. Okay. Now we are going to arrange these letters. Listen. 1, 2, 3, 4, 5, 6, and this one. Total 7. Okay. 1, 2, 3, 4, 5, 6, and this one. 7. So 7 factorial. In that, R repeated 2 times. So 2 factorial. 0. Right. Then for inside the box. Inside the box, we have 5 letters. So to arrange 5 letters, 5 factorial. Divide by O repeated 3 times. O. So 3 factorial. This is the answer. Is it clear? So no need to find the exact value. Okay. So write the vowels inside the box. So we have O 3 times and A and I. So take them as a single unit. Okay. Remaining, we have 6 letters plus this one, total 7. So 7 factorial. In that 7 factorial, we have R repeated 2 times, right? So divide by 2 factorial. Into, inside the box, we have 5 letters. So 5 factorial. Divide by, we have 3 similar letters, right? O, 3 times. So 3 factorial. Is it clear? Is it clear, bro? Any doubt? Any doubt? We have a similar, want to arrange the words with vowels always together. Okay, final one. Optical. Optical. Vowels always together. Give a try. Vowels always together. The word optical. So what is the answer here? Vowels always together. Okay. So what are the vowels here? O, I, A. Okay. The remaining P, T, C, L. Good, Hemant. Good. So P, T, C, L. Right. So 1, 2, 3, 4, and this one. Total 5. So 5 factorial. There's no similar word, right? All are different. So into, again, we're coming for the vowels. Inside the box, we have 3 letters and 3 are different. So 3 factorial. That's all. Yes, good. Yes, most of the words right answer. Good. Is it clear now how to arrange the words? Any doubts by an arrangement? Shall we try the question number 1? Very easy topic, but real-time examples all we have. Shall I clear this page? Shall I move to the next one? Question number 1. Okay. This is an example. Okay, this is an example. Yeah, Akash, after 11, I will give a combination topic. This is only for permutation. First set of questions you have only for permutation. Okay. After 11, I will teach you the combinations concepts. Okay. Listen carefully. A zip code contains 5 digits. Okay. A zip code contains 5 digits. Zip code contains 5 digits. How many different zip codes can be made with the digit 0 to 9? If no digit is used more than once and the first digit is not 0, you already know that if you apply 0 as a first digit, then it becomes 4-digit number, right? So 0 will not be the first digit. Okay. So we have from 0 to 9, we are going to form a 5-digit number. How many number of ways you can use this? Okay, this is an example, ma. Okay, this is an example. Page number 173. Okay, but this is an example question. Give a try. So you're going to find here you have a 0, right? Here you have a 0. So now you need to find the exact value, ma. Okay, right? Okay, in this place, from 0 to 9, how many digits are there? From 0 to 9, how many digits are there totally? Yes, good. 10 digits, right? Total 10 digits. In the first place, 0 is not possible. Okay, in the first place, 0 is not possible. So, out of 9 numbers, anyone can be placed here. Okay, the next. Actually, Charan, the no digit is used more than once. So, repetition is not allowed. Here the question is, repetition is not allowed. So one number is placed here. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay. In that, 0 is not possible in the first place. So out of remaining 9 numbers, 1 is placed. So for example, I am taking 4 here. So I have placed 4. Okay. Now, 4 is placed in the first place. The second place, how many numbers are possible? Now 0 occur, right? Now 0 may be in the second place. Again, we have 9 numbers. Out of 9, anyone will come in the place, second place, right? So anyone. For example, I take 3. Okay. Again, third place. How many numbers are possible? 8. Good. We have 3 plus 5, 8 numbers. So 8 ways. Then the fourth, 7 ways. Then the last one, 6 ways. So we need to multiply it. Okay. So don't find the exact value here. Right as it is. So we have total number of ways. 9 into 9 into 8 into 7 to 6. If 0 is one of the digit, then it will be in the first place. But 0 may occur in the second or third or fourth or fifth. Is it clear? Okay. So no need to find the value, but leave as it is. Okay. Once again, repeat this question. So we need to form a 5-digit zip code. We have digits from 0 to 9. Okay, 0 to 9. The given that no digit is used more than once, so repetition is not allowed. Okay. In the first place, we have total 10 digits. Total 10 digits. Out of 10 digits, 0 is not possible in the first place. So remaining 9, out of 9, anyone will occur here. Total 9 ways. Anyone possible, right? For example, if I take 7 as placed here, okay, the no digit is used more than once. So 7 will not occur once again, right? Again, in this place, now 0 may occur. Out of 10 digits, 1 is placed. Okay. For example, 7 is placed in the first place. So remaining we have 9 digits. So again, we have 9 ways. Anyone, for anyone placed. Third place, two digits already over. Remaining 8 digits we have. So 8 ways. Again 7 ways, then 6 ways. Since repetition is not allowed. So total you will have 9 into 9 into 8 into 7 into 6 ways. Is it clear, Deepan? Deepan, is clear or not? First place, you should not write 0. That's all. That is the case. Okay, we will move to the question number 1. So how many words? Page number 173. Okay, you should not write 9p5 since 0 is there, right? So find each and every letter. So page number, I think 173. Page number 173. Question number 1. How many words with or without meaning of 3 distinct letters, different letters of English alphabets are there? How many letters are there in the English alphabet? 26, right? Good. 26. In that, we are going to select 3. Going to select 3. That's all. And we are going to arrange it, right? Without meaning, we are going to form a 3-letter word. So we have to arrange it. So from 26, 26, 25, 24. From 26, 3 numbers. Here, the given options are there, right? So we need to multiply it. So if you multiply it, you will get 15600. Okay. So 25 into 4, I will split like this. 26 into 25, 24, I will write like this. So 25 into 4 easily 100, right? Into 6, it becomes 600. So 6 times. The answer must end with, okay, last 2 zeros compulsory. So 6 6 are 36, right? So we have option 15600, but we have option none also. So just multiply it. To multiply, you will get 156. So clear? Option C is good. So clear, but so we're going to form a word of 3 different letters out of 26. We are not selecting, we are going to form. Form is even arrangement. Okay, select 3 letters and arrange them in the order. So using permutation, 26p3. So clear, one. Try the second one. Second, sorry. I think already we have completed this question. Second one. So out of sorry, out of 5 digits, 1, 2, 3, 4, 5, we need to form a 3-digit number. Okay. So out of 5 digits, we need to form a 3-digit number, right? So you can write like this, 5p3. So 5 into 4 into 3. From 5, 3 numbers reverse. We get 60. Yes, good. Or else anyone can replace the first place, right? Again, second place 4 without repetition, right? Without repetition. So number you not repeat it once again, right? So 5 into 4 into 3, you will get 60. Is it clear? Is it clear now? Okay, try the third one. Give a try. Give a try. The third one. So how many different ways can the letters of the word leading? Okay, leading can be arranged. Okay, in such a way that vowels always together. Some of them are getting answers 720, some of them are getting answers 360. Okay, so leading, in that write the vowels in the box. E, A, I. Right inside the box. Okay, good. Most of them are getting 720. Good. So write the vowels inside the box and treat them as a single person. And remaining letters are L, D, N, G. Okay. So now we have 5 letters. 1, 2, 3, 4, and 5. So 5 factorial. Then E, A, I. We have 3 letters inside the box. So arrange the 3 letters. We have 3 factorial. So 120 into 6. The answer is 720. Is it clear? Yes, Ruba. Good. Yes. Most of them got the right answer. Good. So arranged. Arranged is nothing but permutation. Okay. Arrangement, selection, and arrangement. So order is important here. So we are applying permutation concept. Next one, give a try. Fourth one. In how many ways letters of the word leader be arranged? Leader be arranged. Yes, Sayed. Any doubt? We have to first initially we have to treat them as one. Okay. If you place E, AIB here or AIB here like this, or AI like this, or IA like this, right? Okay. So we have many arrangements inside the box. So first, if I treat them as one, if I arrange only one person, the remaining 2% may sit like this or they will sit like this. Afterwards, we will find that the main thing is 3 factorial. Okay. So first we will arrange only one person. So we treat the vowels as a single. So 1, 2, 3, 4, then plus 1. This is 5 factorial. Since we are going to arrange this person also. Then inside the box we have 3 letters, right? To arrange 3 letters, we have 3 factorial. In that case, we have this kind of options are there, possible ways. Okay, sir. Always you treat the vowels as a single person. Then inside the box, again, you have to arrange them. Okay, done. So now leader to be arranged. There's no condition. So 1, 2, 3, 4, 5, 6. So 6 factorial. Divide by E repeated 2 times. So by 2 factorial. So 6 factorial value is 720 by 2. You will get 360. Yes, good. Option is C. That's perfect. Okay. You can try the 5th one. How many ways can letters of the word leader be arranged? The answer is 360. Do you have any doubts up to 4th? Okay. So moving to the question number 5. Charan getting 10, Suresh getting 20, Karan 20. Okay. So how many 3-digit numbers can be formed from the digits 2, 3, 5, 6, 7, 8, 9? We have 6 digits. But we are going to find only the 3 digits. And the number should be divisible by 5 and none of the digits should be repeated. Okay, so most of them getting 20. Okay. So we are going to form a 3-digit number, right? And then form number must be a divisible of 5. Okay, what is the rule for 5? If a number is divisible by 5, what is the condition? What is the condition for 5? Divisible rule for 5. Last digit, yes, good. So last digit is either 0 or 5. Okay, last digit, I think about this one. Yeah, either 0 or 5. But in our question, we don't have zeros, right? We have only 5. How many times we have? Only one time, 5. So 5 will occur here. Only one way. Since we have only 1 5. So we have only one way, right? Only 1 5. So 5 placed in the first digit. Here. Unit digit place. Okay. Then this place will be filled by 1, 2, 3, 4, 5. We have 5 numbers, any one. So 5 ways. Then repetition is not allowed, right? For example, if I place 7 here, then the remaining we have 1, 2, 3, 4. 4 ways. That's all. So answer is 5 into 4 into 1, 20 ways. Is it clear? Okay, so once again I will repeat this question part. For divisible rule of 5, the form number must be a multiple of 5, right? Divisible of 5. So last digit or unit digit. Okay, the unit must be either 0 or 5, right? 0 or 5. But in our question, we have only 5, no zeros. So first we need to fill the unit digit place. So unit digit must be either 0 or 5 to get divisible by 5, right? So we have only 1 5. Therefore, only one way. We can ask 5 to come and sit here. Okay, 5 will be placed here. Then remaining 2 places. Now, this place was filled by any one of the 5 numbers. We have 5 numbers remaining, right? So any one. So we have 5 options, 5 ways. Repetition is not allowed, right? None of the digits repeated. So already 1 is over here and also 1 over. Out of 6, 2 over. Remaining 4 numbers, any one will be placed. So answer is 5 into 4 into 1. Value will be 20 number of ways. Okay, should not add it. Should not add, okay? You have to multiply it. Since we need 3-digit number, right? So first place, second place, and third place. That gives you 3-digit number. Therefore, under. So in probability topic also, you will get same type of questions, but actually probability is derived from this concept, permutation combination. Okay, so and means into, or means plus. I will give you example for or. Okay. Is it clear, Bert? Question number 5 up to 5. Any doubts? No, ma. Ruba, actually we are placing one number, right? We are not arranging. We are actually arranging, but we are taking individual places. So in this place, which number can occur? Individual. So out of 5 numbers, any one will come and sit here. Okay, so out of 5, any one. You're going to select, right? I'll tell you, teach you that later. But right, you can think logically. Out of 5 places, out of 5 numbers, we have one place to fill. So for all the numbers, they have a possible to come and sit here. So 5 ways. Like that, you have to move it. And the previous question, we have taken 5 numbers to arrange it, right? So see, for example, leader, I think. Leader, L, L, D, R, something like that. Previous question, we have, okay, so we have L, B, R, then we have E, E, A, something like that. We are going to arrange it, right? 1, 2, 3, and 4. So to arrange 4 letters, we need 4 factorial. But we are going to replace. Out of 5 numbers, I'm going to place any one. So all the 5 are possible chances, right? Like that, we are applying it. Here we are arranging. We are going to form a word. I am taking overall. I am taking overall here, including the vowels. Okay, but here taking individual place numbers for each place. Okay, done. Sixth one, how many 4-letter words or with or without meaning can be formed out of letters logarithms? Repetition is not allowed again. Actually, Rupa, once again, I will explain that question. I think it's leading, right? Leading or leader? In leading, we are going to form a how many letters word? How many different ways the letters of word leading can be arranged so that vowels can be together, right? So E, A, I. So inside the box, writing the vowel, remaining L, B, N, G. So we are going to form a word using all the letters. Okay. So 1, 2, 3, 4, and 5. So total 5 letters, so 5 factorial. We are not writing like this. I write 5 places, and in this place, how many letters are possible? So 1, 2, 3, 4, and one total 5 letters, right? So any one may occur. So you can write 5 here. Then remaining 1, 2, 3, 4, 4, then 3, then 2, 1. This is 5 factorial. Instead of writing like this, I'm writing overall. Clear? Then I'm going for vowel. We have 3 vowels are there. To arrange 3 letters, we have 3 factorial. Again, you have to write 3 letters. E, I, A. Out of E, I, A, anyone will occur, right? E. Then here A, anyone out of. So 3, here 2, here 1. Nothing but 3 factorial. So instead of writing like this, we have formed a ways like this, right? It's clear? Clear, Rupa? Okay. Yes. Okay, someone asking for answer. Okay, how many 4-letter words are without meaning can be formed and no repetition is not allowed? Here we have logarithms, right? 4-letter word. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How can we like that? How can we write this? Yes, good. 10 P4. Out of 10 letters, we need only 4. Right? So from 10, 4 numbers reverse. 9, 8, and 7. So 90 into 56. The answer should end with 40, right? Since answer will always end with 0, since we have 0, 9, 6 are 54. Answer will end with 4. So we have only option is 5040. Yes, good. 10, 9, 10 into 7. Good. And Meera, the answer for leader is 1, 2, 3, 4, 5, 6, right? 6 factorial and divide by E similar. So by 2 factorial. So you will have 720 by 2. Answer is 360. This is for 4th one. Okay. So clear, Bob? You have to divide, Siddharth, if you have a multi-cell in the same question, then 10P4 divide by that value. Thus, if you have a multi-cell, for example, R repeated twice, that will 10P4 divide by that R 2 times, right? So 2 factorial, like that. Okay. Okay. Question number 7, but give a try. Question number 7. Okay, Mira. In how many different ways? Okay. Everyone is getting same answer and you good. Already we have done that, right? And how many different ways the letters of the word optical can be arranged? The vowels always come together. Vowels always come together, right? So O, I, K. Remaining we have P, T, C, L. P, T, C, L. So 1, 2, 3, 4, and 5. So 5 factorial. Okay. Then inside the box we have 3 letters. So to arrange 3 letters we have 3 factorial. So 120 into 6, 720. Clear? Yes, shall be good. Is it clear, Pam? Any doubts after this? Question number 7. Okay. So 8th one. And before that, for example, you have a okay. Read the question here. So assume that all the 7 flags are transmit a signal, but if you take red, all the red are similar. If you take yellow, both yellows are similar, same color, right? If you take green, both are green, same, similar, like apple. Do you remember that? 5 factorial divided by 2 factorial, right? The same condition you're going to apply here. So how many different signals can be transmitted? Okay, by arranging 3 red, 2 yellow, 2 green. Assuming that all the 7 flags are transmit signal. Okay, so all will transmit signal, right? You can use 2 red to transmit signal. How many different signals, right? So all the flags are used to transmit signal. Okay, so total 7 flags, right? 3 plus 2 plus 2, 7 flags. So 7 factorial. Divide by red are similar. So 3 red are similar, 2 yellow are similar, 2 green are similar. Yes, most of them got the right answer. Good. So 7 factorial. So 7 into 6 into 5 into 4 into 3 into 2 into 1. If you know the value, you can write directly. 3 factorial, 3 into 2 into 1, 2 factorial, and 2 factorial. So 3, 2 into 1, it will out. 2 2s are 4, right? So 4 out. Remaining we will have 7 into 6 into 5. So 7 into 6 into 5 is 210. This is the right answer. So clear? So clear, well? Okay. Second, you can take any flag for signal, right? You can take red, yellow, or green. So we have 7 flags. 7 will use to transmit the signal. Therefore, 7 factorial. Going to arrange 7 flags. 7 factorial. In that, red similar, yellow similar, green similar. So you are dividing by some factorial. 3 factorial, 2 factorial, and 2 factorial. Like a word, arranging the letters, right? Similar to that. Since red are similar, right, Zibban? We have 3 red, right? All the red are similar. R. If you have yellow, both the yellow are similar. Same letter, like same letter. Like in apple, we have 2 P's, right? You divide by 2 factorial if it is similar. Like that, here we have 3 red, 2 yellow, and 2 green. So total, we are going to arrange it. So 1, 2, 3, 4, 5, 6, 7. So 7 letters, 7 factorial. In that, R repeated 3 times, Y repeated 2 times, and green G repeated 2 times. Is it clear now, Deepan? Okay, done. Instead of writing like this, similarly they given the 3 red, 2 yellow, and 2 green. But actually, the letter was like this. We need to arrange that. Okay. Try the ninth one. Okay, I will clear this page. So in how many ways 5 apples, 4 bananas and 3 mangoes can be arranged in a row? Okay. In how many ways 5 apples, 4 bananas and 3 mangoes? So totally we have 12, right? Totally we have 12. So 12 factorial. And apples are similar. So 5 factorial, 4 factorial, 3 factorial. So option A. Yes, sir. Good. So we are finding in the row nothing but linear arrangement. We have learned only the linear arrangement. Okay, linear arrangement, 3 people, 3 chairs, 3 factorial, right? NPN, 3 factorial. Going to arrange lower cost, linear arrangement. So 4 factorial. Suppose, actually answer is A option for this one. If it is a circular arrangement, for example, dining table. Okay, circular arrangement, loop. So we have, suppose if in linear, to arrange 3 people, 3 factorial. To arrange 4 letter, 4 factorial, right? 4 people, 4 factorial. In circular arrangement, if we have 6, in how many ways you can arrange them? Any idea? In linear, it is n factorial, right? In linear, it is n factorial. But in circular, it is n minus 1 factorial. Okay, in circular arrangement, it is n minus 1 factorial. We have 6 letters or 6 people you want to arrange in the dining table and write as 5 factorial since n minus 1. Okay, if you ask 6 person to go and sit in the dining table, they will run like a musical chair type, right? If you place one person here, you will blocking. Okay, you're blocking the circular arrangement. If you place one person here, the remaining 5 will sit in any place, or else they will go like rotation basis, right? Like a circular. Okay, so instead of avoiding that, I'm blocking that person. Okay, I'm going to arrange one person in one place, so remaining 5 can sit in any place. Therefore, in circular arrangement, answer is n minus 1 factorial. For linear, n factorial. For circular, it is n minus 1 factorial. So make a note of this part. For circular arrangement, n factorial. Sorry, linear arrangement, n factorial. For circular arrangement, n minus 1 factorial. 1 to block that circular arrangement. Okay, the remaining 5 will sit in any other place. Okay, try the 10th one, give it a try. A family of 4 brothers and 3 sisters are to be arranged. Second permutation. For circular, it is n minus 1 factorial. But for linear, it is n factorial. So instead of letters and vowels, we have brothers, sisters. Instead of vowels, we have all the sisters are together. Okay, so we have 4 brothers, right? B1, B2, B3, B4, and 3 sisters. All sisters sit together. So consider them as a single. Okay, so we have 1, 2, 3, 4, and this one 5. Total 5 factorial into to arrange 3 sisters, 3 factorial. Since a linear arrangement for a photograph, you will sit in a row, right? They're given in the row. Row is even linear. So as it is, 3 factorial. So answer is option B. They're given in terms of that. So clear, but instead of letters and vowels, they're given brothers and sisters. So all the sisters are together. So make them inside the box. And we have one B1, B2, B3, B4 plus 1 box, total 5. So to arrange 5 numbers, 5 factorial. Inside the box, we have 3 persons, right? So 3 factorial. Is it clear, bang? Any doubt up to 10th? Any doubts, bang? Yes, Sayed. Yes, ma. Here we won't divide since they are all different, right? 4 brothers and 3 sisters. They didn't mention any twins like that. They are all different letters. Sayed, we cannot write 7 factorial since they given that all these sisters sit together like vowels. Okay, all these sisters sit together. So we are going to arrange the sisters cases that they are always sit together. Therefore, you have to take it as one person. If you arrange S1, you know the any one of the place, remaining S2 and S3 and go and sit like this or like this. Is it clear? Similarly, like the letters problem. They given the condition that sisters always sit together. Is it clear, Bal? Up to 10? Give a try, 11th one. Give a try. Okay. So you're getting 240. Most of them getting 240. Good. So how many 6-letter words could be made out of the letters word simple if the word must begin with a vowel? Okay. So write 6. I will make 6 dashes. Okay. We have simple word, but this letter, this word must begin with a vowel. So how many vowels we have? How many vowels we have? 2, right? I and E. The first place was filled with either I or E, right? The first place was filled with either I or E. Should begin with vowel, with or without meaning. Okay. So either I or E must be comes to the place in the first place. So there are 2 ways. Anyone. So 2 ways. Okay. For example, if I place E here, then the second place, how many possible are there? How many ways? 1, 2, 3, 4, 5, right? So 5 ways. Then here 4 ways. Here 3. Here 2. Then 1. Is it clear? So answer is 2 into 5 into 4 into 3 into 2 into 1. If you multiply it, you will get actually 5 into 4 into 3 into 5 factorial, right? So 2 into 120, 240 ways. Is it clear? So only one condition is the word must begin with a vowel. So we have 2 vowels. Out of 2, anyone will replace this place. So we have 2 ways. So one is replaced with E. The remaining we have 5 letters. So 5 places. We have 5 letters and 5 places. Can directly say that 5 factorial. Can take any method, Maruba. Actually, I'm taking individual, right? In each place I am filling. So I'm taking as a ways, number of ways. All the letters are, if you combine, you will get a 6-letter word. So I'm multiplying it. Okay. Can take any one method. Okay. Actually, in the first place one alone, we have a condition, right? The first word begin with a vowel. We have only the first place. Remaining 5 letters, no conditions, right? So this place must be filled either with I or E. We have 2 vowels. So out of 2, anyone will come in the place. So we have 2 ways. So remaining 5 letters, 5 places. So nothing but 5p5, right? Nothing but 5 factorial. To replace these letters, okay, we have 5 letters, right? 5 places, 5 letters. So 5 factorial. So 2 into 5 factorial. Can write like this or can go any individual places. So once again, I repeat this question. So how many 6-letter words can be formed? So I'm writing like this. Okay, with using the word simple, but the word must begin with the vowel. This is the condition here. The word must begin with a vowel. So this place to start with a vowel, right? So we have 2 vowels in the word simple. Maybe either filled with either I or E. So 2 possible chances, right? So 2 ways. anyone will come in the place. Okay, suppose if first place is filled with E, then the remaining place has no condition, right? So we have 5 blanks and we have 5 letters. Okay, we have 5 blank and 5 letter. So to fill 5 blanks, 5 letters, 5 factorial. Nothing but 2 into 5 factorial. Answer is 240. Or each and every place you have to find the number of ways. Is it clear? We have 5 blank and 5 letter to place. Something but 5p5. 5p5 is 5 factorial. Or else you need to go by each and every place. 5 ways, here 4 ways, here 3 ways, here 2, here 1. Both the same. Is it clear, Bob? Any doubt? Syed? Okay, any doubt up to question number 11? Okay. Yes. So question number 12. Okay, we'll find it. So how many words can be formed? The letters of the word omega. Okay, most of them got the right answer. Yes, Sanju. Yes, Surya. Good. Omega. O and A occupy the n places. O and A occupy the n places, right? Case 1. So we have 5-letter word omega. In that, first one is O and A occupy the n places. Either you can have OA here or AO here. Okay. To fill the last places, how many possibles are there? If you fill O here, then A will be in this place. Suppose if you fill A in the first place, then definitely O will be the last place. So we have 2 ways, right? Is it clear? The occupy O and A occupy n places, right? O and A occupy the n places. Either O is in the first place or O is in the last place. We have only 2 chances. Is it clear? 2 ways. The remaining 3 can be filled with the remaining 3 letters. M, E, G. So 3 places, 3 letters. So answer will be 3 factorial. Is it clear? N place means nothing but n places, right, ma? This is also one end, this is one end. We have both ends, left and right end. Right? N places meaning that it may be a left end or right end. So 2 places. If filled with O here, then A will be here. Or if A, no, only 2 possible ways, only 2 ways. Is it clear? Then remaining 3 places must be occupied with remaining 3 letters. So 3 place, 3 letters. So 3 factorial. So 2 into 6. Answer is 12. The first one answer is 12. So option C and D are eliminated. Yes, Siddharth, correct. And the C and D are eliminated. Is it clear? Aishwarya, it is clear, ma? N plays nothing but both the ends. Maybe left and right end. Okay, the first one answer is 12. So please make a note of this. I'm going to clear this. Okay, the second one. I'm coming, Rupa, coming. So E being always in the middle. Okay, E being always in the middle. So we have 5-letter word. E must be in the middle. There is only one way. Since we have only one E, right? Only one way. Then the remaining 4 letters has no condition. So remaining 4 places can be filled with 4 letters. So 4 letters, 4 places. Answer is 4 factorial. 4 factorial into one way. One is nothing but for E to place in the middle. The answer is 24 into 1. 24. So 12, 24. So we have two options. For A and B, both we have 12 and 24. Is it clear up to this? Any doubts? Conditions 1 and 2 is clear or not, man? Okay. Now, listen carefully. I'll give an example. Okay. Then I'll move to the option 3, condition 3. Okay. Now, in red, read. Okay, read or read. Okay. Vowels always together. So what is the condition? If there's no, what is the first case? We have 3 cases. First one is no conditions. Okay, you can arrange any without meaning. You can arrange 4 letters in different 4 places. Okay. So what is the condition? If you want to arrange read, you want to arrange read. What is the condition? What is the ways? Number of ways? There's no condition. 4 letters, 4 places. So 4 factorial. This is the total number of ways. So clear? This is the total number of ways. No condition. Okay, you can replace any place with any letter. Okay. Now the second condition is vowels always together. Vowels always together. So in that case, you take E and A as a single place and R and D. So 1, 2, 3. So 3 factorial, and again to arrange E and A 2 factorial. 12, right? Is it clear? So R and D 1, 2, and E and A 1 person. Total 3 persons. To arrange 3 persons, 3 factorial, and E to A arrange 2 factorial. Is it clear, but this is no condition, nothing but total number of ways. Total number of ways to arrange read is 24. Suppose vowels together, then the case is 12. Okay. Now the third point is no vowels being never together. Vowels never together. Then what is the answer here? Vowels never together. So we know that total number of ways is 24. In 24, there may be vowels together or never together, right? In that 24, if you subtract 12, 12 is the vowels together, right? Subtract, you will get 12 ways for never together. Is it clear? Okay. First condition, 4 factorials. We need to arrange the 4 letters, that's all. To arrange 4 letters, we have 4 factorial ways. Second condition, vowels always together. So for that, we have 12 ways. The third condition, vowels never together. So out of 24, if you subtract vowels together, you will get vowels never together. Is it clear, Bang? It's clear or not? Okay, like that, we are going to find the third condition. Okay, we're going to find the third condition. Now, please make a copy of this. I'm going to clear this page. Okay. So listen carefully. The third one, vowels being never together, right? So I'm going to find to arrange this word omega. To arrange the word omega, 5 letters, right? To arrange 5 letters, you have 5 factorial. The answer is 120 ways. Next one, I'm going to find vowels together. So vowels together. So MG and OEA. Vowels together. So 1, 2, and 3. Total 3. To arrange 3 people, 3 factorial. Into, again, we have 3 letters inside the box, right? To arrange them, we have 3 factorial. So 6 into 6, 36 ways. This is for vowels together. But the question is, vowels being never together. So out of total number of ways, if you subtract the vowels together, you will get vowels never together. So clear? The answer is 12, 24, and 84. Is it clear? Any doubt? Any doubt? You have question like this, never together, then find the overall number of ways, then subtract the together ways. Okay, we'll get the value. Any doubt after question number 12? Any doubts up to question number 12? Any doubts? Yes, sure, mister. If you are clear, you can go for 13th one, ma. Yes, sir, mister. What's the doubt, ma? In which place, ma? In which question? Okay, actually, in case of red, first you need to arrange all the letters, right? To find the total number of possible ways, you need to arrange all the ways. So 4 factorial. Then this is for all the possible outcomes, right? All the possible outcomes. Total number of ways is 4 factorial ways. This is total number of ways. Next condition is vowels together. Vowels together, right? Vowels together means you have to write EA as a one person and R and D other 2 persons, right? So 1, 2, 3, total 3 persons, 3 factorial into, to arrange these 2 persons, maybe EA or EAE, right? So 2 ways again. We'll get 12 ways. The vowels never together means should not write this like this. Since 3 factorial you are considering only the 3 letters. 1, 2, 3, right? Subtract 2 in that. That means you're not never considering E and A letter. If you subtract 2 factorial there, then you're not even considering either AE option or EA option. That means you're considering only the R and D. Okay, you're not considering EA in the arrangement. Actually, you have to arrange E and E, but they should never together. That's the meaning here, like this maybe. Okay, that's why you're applying 24 minus 12. 24 nothing but all the possible outcomes. Maybe never, maybe together or never together. Okay. In that, if you subtract always together, you will get the never together value. Nothing but, okay, we have 4 places, right? If you place R and D here, maybe EA or AE. Okay, ma? Or if you place RD here, maybe EA or AE. Like that, you can arrange it, right? Similarly, if you place D here, R here, so again, many number of ways. Up to 12, you will get like that. So clear, ma? Okay. Now the question number 13. Read the question carefully. I think Siddharth will answer this question, I think. Okay, there are 5 tasks, 5 persons. Task 1 cannot be assigned to either person 1 or person 2. Okay, then for task 2 must be assigned to either person 3 or person 4. Okay, Anju also got 24. Okay, we'll see that now. Okay. So I will draw a line like this. Okay. So task 1, task 2, task 3, task 4, task 5. Okay. So we know that task 1 cannot be assigned to person 1 or 2. Okay, task 1, 2. And task 2 must be assigned to, sorry, task 1 cannot be assigned to person 1 or 2, right? So not possible for task 1. Task 2 must be assigned for either 3 or 4. But every person has to be assigned for each task. Okay. So listen carefully. I'm taking 2 conditions. Suppose if task 2 is assigned for 3, what will happen? Okay. Similarly, case 2, if task 4 is assigned for Task 2 is assigned for 4. For example, we have a task 2 condition. Task 1, task 3, task 4, task 5. Okay. There's the same. So listen carefully, but now I am going to apply. Actually, given that task 2 must be assigned to person 3 or person 4. Okay. Suppose if I assign task to for person 3, what is the number of ways? If I assign task to for person 4, what is the number of ways? That's all. Maybe either case 1 or case 2 or here. Either case 1 or case 2. So or means nothing but plus. Need to add both the number of ways. Clear? Okay, so listen carefully. If task 3 is assigned to, person 3 assigned to task 2. Okay. What are the number of ways for assigned for task 1? 1 and 2 is not possible. Person 1 and 2 are not possible. So remaining, how many number of ways we can assign a person to task 1? How many number of ways per? So listen carefully. Once again, I will explain this question. Listen carefully. We have going from this option. Task 2 must be assigned to either person 3 or person 4. Okay. So case 1. If task 1, 2, 3, 4, 5, in that task 2 must be assigned for either 3 or 4, right? So if I assign task 2 for person 3, what will happen? Okay. Similarly, case 2, we have task 1, task 2, task 3, task 4, task 5, right? Task 2 must be assigned only for either 3 or 4. If I assign for 3, what is the number of ways? If I assign for 4, what is the number of ways? That's all. Okay. Now, listen. Now, task 1, person 1 and 2 are not possible. Okay. So, in how many ways the task 1 will be filled? Assigned. 2 ways. Good. Right. Since either it may be a 4 or 5. Since 3 is assigned to task 2. So, task 1 and 2 cannot be possible. Remaining 2 persons may be possible, right? Either person 4 or person 5 can be assigned to task 1. So only 2 ways. Okay, only 2 ways. Anyone will be assigned. Is it clear? So already here one person assigned, either 4 or 5. Here one person assigned. In task 3, how many possibles are there? Now we have 1, 2, then remaining 1, either 4 or 5, right? One person will be assigned for this task. For example, if I assign 5 here, then 4 will be here. If I assign 4, then 5 will be here. So we have 3 possible ways. So 3 ways. So clear? Here only 1 way to assign a person. Then out of 3, 1 is assigned to task 3. Remaining 2 ways, then 1 way. Is it clear? Is it clear or not? Once again, I will repeat. Once again, I will repeat. Okay, listen carefully. I'm starting from the case 1. Okay, we have 2 cases. So task 2 must be either assigned to 3 or 4. Suppose if I assign to 3, what will happen? This is the question here. If I assign to 3, there's only 1 way. We have person 3 only 1, right? So only 1 way. Or else, if you assign task to person 4, what will happen? How many number of ways you will get? This is a question. Okay, so I'm starting with, suppose if I assign task 2 to person 4, there is only 1 way. 1 person is 4. Okay, now 1, 2 is not possible in task 1, right? Now we are going to fill task 1. Already 3 is filled in task 2. Okay, we have only 5 persons. Task 3 is already filled, and task 1 and 2 is not possible in task 1, right? Person 1 and 2 not possible in task 1. So remaining we have 4, 5. So out of 2, anyone will occupy this place, right? So anyone. So we have 2 ways. Anyone will come in the place task 1. Okay. Now we are going to task 3. So already we have 1 and 2 left over. Then out of 4 and 5, 1 will be here. Anyone. Either it may be 4 or 5. Okay. Anyone. So we have 3 persons, right? So there's a 3 chances, 3 ways. can assign task 3 to anyone. Okay, anyone will be assigned to task 3. So remaining 2 will be assigned for task 4 and remaining 1 will be assigned for task 5. So clear? So total number of ways equal to 2 into 1 into 3 into 2 into 1. Answer is 12 ways. Is it clear? Is it clear, but the same method you're going for. Suppose if task 2 is assigned for 4, what will happen? Can get either case 1 or case 2 or nothing but plus. Okay. If 4 is assigned to task 2, then only one way. Now, remaining we have 4 already assigned to task 2. Remaining we have 4 ways, 4 numbers, right? But 1 and 2 is not possible in T1, task 1. So we have 3 or 5. So either 2 ways. Any one will assign to task 1. Okay. Similarly, we have 1, 2 or 3. Suppose if 5 is assigned here, we have 3 persons, right? So 3 persons, 3 ways to assign. And finally, 1 person will be assigned for task 4 out of 2, then 1. Again, you will get 12 ways. So total answer is 24 ways. Either case 1 or case 2. 12 plus 12, 24. So you have total 24 ways. Is it clear, Bal? The question is assigned to either person 3 or person 4. So if it is person 3, what is the case? Or means plus, right? So if it is 3 in task 2, what is the number of ways? If it is person 4 in the task 2, what is the number of ways? That's all. Each person must be assigned to each task. One task, right? Therefore, from the task 1, we cannot take 1 and 2, already 3 is assigned. Remaining 4 and 5, any one person will occur, right? So we have 2 chances, 2 ways. 1 will be assigned. So remaining 3 persons will be there. Already task 1 and task 2 are assigned. So remaining we have 3 persons, 3 tasks. So 3 factorial. You can write like that also. Okay. The main condition is for the 1 and 2. Okay. Remaining we have 3 tasks, 3 persons. We can write 3 factorial. 3 factorial into 2 ways into 1 way. You can write like that as well. We will get 2 at 12. Similarly for this, the main condition is for to assign T1 and T2. Remaining 3 tasks, 3 people. So 3 factorial. So 2 into 1 into 3. You will get 12. 12 plus 12, 24. Is it clear, Bal? Any doubts? Yes, sir. You can take it. Yes, Suresh, you can take it. Instead of considering 2 cases, in task 2, you can take 2 ways. Okay, so this is one method, or else you can write like this. This is task 2. So task 2 is filled by either 3 or 4, right? So 2 ways. So clear? Task 2 must be filled with either 3 or 4, any one. So total 2 ways. Similarly, in task 1, 1 and 2 are not possible. Already 1 person is filled here. Remaining you have 2 persons, right? Total 3 persons, total 5 persons. In that 1 and 2 is not possible for task 1. Out of 3 and 4, anyone is placed in the task 2. Remaining you have 2 places, right? So 2 ways. That's all. So 2 tasks filled. Remaining 3 tasks, 3 people will be there. 3 tasks, 3 persons. It's nothing but 3 factorial ways. Therefore, answer is 2 into 2 into 3 factorial. So 24. Can write like this also. So clear? Second method. Okay. Task 2 either filled with either 3 or 4. So 2 ways. Okay. Anyone will be assigned the task 2. Remaining we have 4 people, right? 1 is assigned for task 2. For example, if 4 is assigned to task 2, remaining 4 people we have, but in task 1, 1 and 2 are not possible. Remaining 2 persons, we have to assign task 1. So again, we have 2 ways. So for 2 tasks, 2 persons allotted. Remaining 3 tasks, 3 persons. So 3 factorial. The total number of ways equal to 2 into 2 into 3 factorial. Answer is 24. Can go by any method. So clear, bro? Is it clear? Any doubts after this? Very easy topic. Okay. So clear or not? Okay. And last one final concept. How many 3-digit numbers are there? How many 3-digit numbers are there? How many 3-digit numbers are there? Okay, 900. Good. How many numbers are between 100 and 100, including 100 to 200? Okay, well, shall I clear this page, pa? Any doubts in question number 13? Any doubts in question number 13? Okay, done. So listen. So we have actually 100 to 200. Okay, question is from 100 to 200. How many different digits are there? For example, 123. 123, all the numbers are different, right? 142, like that. From 100 to 200, how many different numbers are there? Different digit numbers are there? From 100 to 200, how many different digits are there? Different digit numbers are there? Any guess? Actually, from 100 to 200, we have 101 numbers, right? Including 100 and 200. Okay, or else you can take 100 numbers. From 100 to 200, we have 100 numbers, like that. We cannot take 100 P3. If you take 100 P3, it will happen that can maybe like this also, or else like this also. Any 3 numbers, right? So this is not possible. Actually, I'm asking for distinct numbers, 3 distinct numbers. Okay. So listen carefully. Yes, Suresh. Perfect. Good. Listen carefully. Here we have 0 to 9 total digits. We are going to fill. Okay. But the question is from 100 to 200. So what comes to the first place, man? Which digit? The question is for 100 to 200. We have some 0 to 9. We are going to fill in this number. So how many numbers can be possible in the first place? Yes, good. Only 1. Since if you apply 2 here, then if you substitute 0, then if you apply 1, so it becomes more than 200, right? So the first place only 1 is possible. So only one way. Okay, so clear. Second place, remaining we have 9 digits. I'm asking for distinct, different. So digits not be repeated, right? So remaining we have 9 digits. Out of 9, anyone will come here. So 9 ways. Okay, then remaining 8. Is it clear? So answer is yes, it does. Good. Answer is 1 into 9 into 8. Total we have 72 numbers for 100 to 200. So each 100 numbers you can check, if you can verify afterwards. Okay, you can write and see, no issues. Okay, each 100 numbers there will be 72 different digit numbers. Therefore, for 900 numbers, we have 72 into 9. Since for 100 it is 72, right? For 900, 9 times 72 into 9. So what is the answer here? 648 numbers will be there. 648 different digit numbers will be there. Okay, should not consider this also. 101, okay, 110 series up to 119. It's not possible, right? So remaining 72 digits will be different digits. For 900, for 3-digit numbers, all out of 900 3-digit numbers, we have 648 different digit numbers. Is it clear about how to find this using permutation? Is it clear? Any doubts, sir? Okay. In combination, we have only 10 sums per. I will teach you the concept and 10 sums. We will complete before the time today. If you have any doubts, please message me in the box. Or else you can have a break by 11:15 maximum. 11:15 we'll start the class. 11:15 per maximum 11:15. you have any doubts, please message me in the box. Wait for another 5 minutes. Or else you can have a break. Okay, 11:15, we'll start the class. Any doubts? Guys, any doubts? Okay, good. So have a break, 11:15, we meet once again. Any doubts about previous session and permutation? No? What happened? I'm not getting any responses. Please, we have 28 students, 28 students are there. Any responses, sir? Yes, ma'am. Okay, done. Okay, shall we start? It's 11:15, I think. Okay, done. So previously it was actually we learned about permutation. Permutation nothing but selection and arrangement, right? Permutation, selection and arrangement. The NPR equal to n factorial by n minus r factorial. Okay. Selection and arrangement. So in combination, only selection. Only selection. So NCR, representation NCR, n factorial by n minus r factorial into r factorial. Actually, you can write it as n factorial by n minus r factorial, nothing but NPR, right? NPR by r factorial. You can say like this also. Since in permutation we have selection and arrangement. In combination we have only selection, right? So if you divide by the arrangement, okay, you will get only selection. That is the meaning here. That's why we are dividing by r factorial, number of arrangements. If you divide by r factorial, you will get NCR. Okay, NPR by r factorial. S is the selection. I am writing as a short form. Selection into arrangement by arrangement. If you divide the arrangement, you get only selection. That's the combination. Okay, so in combination, order is not important. Okay, order is not important. So for example, if a committee is being selected or committee is being formed out of a 3-member committees to be formed. Okay, what is the value of 10C3? How will you find? First, we will find the value, then we'll move to the concepts. 10C3. Without using the formula, okay, without using formula, do you remember how to find 10P3? 10P3 nothing but from 10 3 numbers, right? Okay. Similarly, for combination, 10C3 from 10 3 numbers, divide by the arrangements. Divide by the arrangements, divide by the r factorial. So 3 into 2 into 1. Is it clear? In permutation, we have both selection and arrangement. Number of ways will be more. In combination, we have only selection, right? So we have to divide by the arrangements. So we have three terms. So dividing by the arrangements. So divide it, you will get 120. So clear? Okay. For example, 7C2. From 7, 2 numbers. 7 into 6. Divide by 1 into 2. You will get 21. So in combination, you have to divide by the arrangements. Okay, you have to divide by the arrangements. Is it clear? So n stands for number of distinct objects. N stands for number of distinct objects, different objects. Okay, or number of objects chosen at a time. Or number of objects chosen at a time. Or places to fill. Okay, C stands for combination. So clear about how to find the values. Okay. Now. Okay. Now. Okay. Now actually we need to travel from A to C via B. Actually A, B, C are cities. Okay. From A to B, we have three mode of transportation. Okay, three mode of transportation from A to B. From B to C, we have four mode of transportations. Then how many number of ways can travel from A to C? And how many number of ways you can travel from A to C via B? How many number of ways you can travel from A to B? Okay, now how many number of ways you can travel from A to B? How many number of ways you can travel from A to B? 3. Good, right? So out of 3, you will choose any one. You can have bus, car, or train. Okay, you can choose any one. So that's 3C1. So we have 3 ways, right? And we have to choose from B to C. Okay, and from B to C, we have 4 mode of transportation, right? Bus, car, train, flight, okay? So from that, you will choose any one. You cannot travel in both the ways, right? For a single time traveling, you have to choose any one. So out of 4 ways, you can choose any one. So 4 possible. So and, right? A to B and B to C. So total number of ways equal to 3 into 4, 12 ways. Is it clear, bro? So we are choosing, right? Out of 3 ways, we are choosing one. Is it clear? Okay. Now, shall I clear this one? The next concept. Okay. So we have 3 pants and 4 shirts. In how many number of ways you can choose 1 shirt and 1 pant and dress it up? For going to a party, I need 1 pant and shirt. Okay. I have 3 pants and 4 shirts. In how many number of ways you can choose pant and shirt for a party? And one more question. You have 3 saris, okay, and 4 chudis. In how many number of ways a woman can dress up for a party? This is actually taken for men, okay? This is for women. In the first case, how many number of ways? In second case, how many ways for women? Okay, so for men, actually first we need to take 1 pant out of 3, right? Then you have to match it with the shirt. So we have 4 shirts. Out of 4, any one must be taken out. Under nothing but we need to wear both pant and shirt. Right? Is it clear or not? For pant and shirt, we have to wear both. Under. So 3 into 4, 12. But in women, we cannot wear both at the same time. Right? Any one Either you can go for saree or you can go for chudi. So out of 3 sarees, you have to choose any one. Similarly, chudis, we have 4 out of 4, and you have to choose one. So or any one. So plus. So 7 ways. Is it clear? Yes, Aishwarya. Good. Is it clear? So NC1 equal to N. NC not equal to 1. Since we are not selecting anything. Okay, same like permutation. So window shopping. Just we will go into the inside a shop, we see the products, and without selecting, we'll move the next shop, right? So NC1 equal to N, NC not equal to 1. NCN is equal to 1. Whereas in permutation, NPN equal to N factorial. You need to arrange all the persons, right? Therefore, we have N factorial. But here, we need 5 pence, okay? The shop also they have only 5 pence. So in that case, you won't select it, right? Just you ask to give all the 5 pence to you. This is only one way. Select all the. We have only n items, but we need n items. So just the number of ways will be only 1. Okay. Then you can say NCR equal to NCN minus R. For example, you have 10 dresses. Okay. I am asking you to select 7. Okay. You have 10 dresses. I am asking you to select 7. Instead of selecting 7, you can reject 3. Right. Out of 10, instead of selecting 7, can I reject 3? Both are same or not? You guys are listening? Okay. We have 10 dresses. We need to select 7. Instead of selecting 7, shall I reject 3 by seeing the color or something design like that? Okay, both will be the same, right? That is the meaning here. So NCR equal to NCN minus R. Okay. For example, I will clear this page. Once again, I will write this. So NCR equal to N factorial by N minus R factorial into R factorial. NC not equal to 1. NC1 equal to N. NCN equal to 1. Okay. Now the next formula is NCR equal to NCN minus R. That means out of 10, you want to select 7. Instead of that, you can reject 3. Shall we find the value for these two terms? So 10C7 equal to, from 10, 7 numbers. 8, 7, 6, 5, 4. Divide by the arrangements. 7 items, right? 7, 6, 5, 4, 3, 2, 1. If you divide it, you get this number, right? So you will get 10 into 9 into 8 divided by 3 into 2 into 1. This is the answer you will get. Similarly, if you go for 10C3, from 10, 3 numbers, 10, 9, 8. Divide by the arrangements, 1 into 2 into 3. So both are same, right? Is it clear? Both are same, right? So instead of selecting 7, I can reject 3. Both the answer will be the same. So this is an example for this formula. Okay? Or some will say like this. NCX equal to NCY. Then x plus y equal to n. Okay? Similarly, in this case, 10C7 equal to 10C3, right? This implies x plus y. X plus y is 7 plus 3, which is equivalent to 10, n. Is it clear, ba? This can apply only when R is greater than half of n. For example, if you want to find 100C98, you want to find 100C98 value, can you find from 100 to 98 till 98 you have to write, right? Instead of 100C98, shall I write 100C2? Both are right. Is it not clear or not? Instead of finding 100C98, can we go for 100C2? Both are same, right? Selecting 98 items, instead of selecting 98, I can reject 2. Both are same. It's very easy for finding the value. From 100, 2 numbers, that's all. Then you can easily divide it and find the value of 50 into 99. Is it clear, Ba? You can apply when R is half of n, more than half of n. Okay, CS 7, right? So for 10, half is 5. 7 is more than 5. So we can apply that rule. NCR equal to NC n minus R. Is it clear, Ba? Any doubt up to this? Okay. Okay. Now, if you have 5 shirts, okay, 5 shirts, 5 are different brand, different colors. In how many ways you can choose one shirt? You have 5 shirts, okay. You need to choose only one. 5 are all different brand, different rate, okay. How many ways you will choose only one? Nothing but what do you do? Actually, you will wear all the 5 shirts, right? You will wear all the 5 shirts since the brand is different. So you will wear all the 5 shirts and we'll see whether which one is comfortable for us, right? So 5 ways. Okay, suppose all the 5 are same brand, same color, same price. You want to select one. How many ways you will select? Good. Answer is 1. Perfect. If the word same, okay, if you see the word same in the question, the answer will be 1. Since all are same, right? For example, same 5 shirts are white color. All are same brand, same size and same price. Then you choose only one, right? You choose one white shirt and we'll wear it, right? Like that, we get any same word, the answer will be the 1. So clear, ba? Okay. Now, the next example. Okay, you have 4 friends, sir. Okay, you have 4 friends. You are inviting them for a birthday party. Okay, our birthday party. In how many ways can you invite them? We have 4 friends. Okay, you are going to invite them for a party. In how many ways you can invite them? You can invite all the 4. Okay, or you can invite any 3, or you can invite any 2, or any 1, or no one. For suppose in today's scenario, okay, the corona case, right? So you won't invite anyone, right? Only the family members, like that. So we have many options. So NC not, which is I didn't invite anyone. I invited only one, most. Okay. Then any 2, or any 3, or all the friends for our birthday party. So we cannot find each and every cases, right? 4C not, 4C1, 4C2, like that. Right? We cannot find each and every cases, right? Instead of that, we can apply 2 power n. The formula is 2 power n. N is number of friends or number of people you are going to invite. So for this example, answer is 16. So clear? So NC naught up to NCN, you will get the value as 2 power n. N is the number of persons or number of people, like that. Okay. For our example, we are going to invite 4 friends. It may be answer will be 16. You can directly apply the formula. Suppose question state like that. At least one person you have to invite. Then what is the answer? At least one person you have to invite. Out of 4, at least one should be present in the party. At least one. Then what is the answer here? At least one must be present in the party. So formula starts from here, right? Answer formula starts from here. NC1, NC2, like that. Up to NCN. So this NC naught moves to right side. It becomes NC naught. So clear, at least one must be present in the party. So 2 power n minus NC naught is nothing but 1. This is the answer. This is the number of ways. Okay, so for our example, 2 power 4 minus 4C naught. So 2 power 4 minus 1. So answer will be 15 ways. So at least one must be present in the party. So question starts from 4C1, 4C2, 4C3, and 4C4. can find the value, you will get 15. It's clear? Any doubts, sir? Is it clear? So try to learn the formulas using example. Okay, it will be very easy. Is it clear, sir? Any doubt? Okay, done. Shall we move to the next question, number 1? I'll clear this. Move to the next question, number 1. From a group of 7 men and 6 women, okay, 5 persons are to be selected to form a committee. So we have 7 men and 6 women. 5 persons need to be selected, right? So combination to form a committee. At least 3 men are there in the committee. In how many ways can it be done? We are going to only select. Okay, not we are going to arrange them in order. Okay, here order is not matter, right? We are going to only select the 5 persons. Out of 5 persons, at least you have to get 3 men. So out of 5 persons, we have men and women combinations, right? In men and women combination, the question is at least 3 men. So we have many cases. At least 3 men. So if we choose at least 3 men, the 2 will be from women. If we choose 4 men, the remaining 1 will be from women. Last case, if we choose 5 men, then 0 will be the case for women. Is it clear? The question is at least. Okay, at least 3 men are in the committee, right? So if we at least the minimum 3 men, then remaining 2 will be the women. If we choose 4 men, 1 will be in women. All the 5 persons are from men, and 0 women are selected. Okay, so listen carefully. We have 3 cases. So case 1, case 2, and case 3. So we need to select, okay, 3 men out of 7. Similarly, we need to select 2 women out of 6. So in case 1, 3 men, at least 3 men we need to select out of 7. And since and into, right? Into 6, 2. Out of 6, we need to select 2. Is it clear? 3 and 2 is equal to 5, right? 5 persons committee. 3 and 2 is equal to 5 persons committee, right? Therefore, into. Is it clear? Is it clear? Similarly, second case, 4 men and 1 woman. Out of 7, you need to select 4, and out of 6, you need to select 1. Is it clear? Similarly, all the 5 from the men side. 7C5 and 6C0. You need to find the value, right? Clearly given that case, either case 1 or case 2 or case 3. Any case 1 will occur, right? So nothing but plus. It add all the 3 values. Is it clear or not, ma? From a group of 7 men and 6 women, okay? You need to select 5 persons committee. In that 3 must be at least men, at least minimum 3 men, maximum 5 may be men. Okay, so if it is 3, what is the case? Or if it is 4, what is the case? Or if it is 5, what is the case? Shall we find the value? So 7C3 from 7, 3 numbers, right? Reverse as usual, but you have to divide by the arrangement. So 7 into 6 into 5 by 1 into 2 into 3. Divide it, you will get 35. 6C2 from 6, 2 numbers, you will get 15. Clear? Similarly, 7C4 is equivalent to 7C3, right? Both are same. So 35. 6C1 equal to 6. 7C5 is equivalent to 7C2. From 7, 2 numbers, 21. 6C0 equal to 1. Just multiply it. So 35 into 15. What is the answer, ma'am? Anyone? 35 into 15. 350 plus 175. What is the value here? Can multiply like this. 35 into 15, right? So 10 plus 5. 350 plus exit half. The one is 525, right? You can write 525 here. Then 35 into 6. 210, right? Okay, I'm not getting here. 210. Then last 21 into 1. 21. So if you add all the numbers, you will get 756. Is it clear? Why? I'm not getting any response. What happened? Do you have any doubts? Do you want me to explain once again? Okay, Charan, done. So I'll clear this page. Okay. So please take a screenshot back. Already please take a screenshot. I'll explain once again. Okay, Charan. We need to select 5 persons, right? We need to select 5 persons. We have 7 men and 6 women. Okay, we have 7 men and 6 women. The case, actually, we need to select at least 3 men. So at least 3 men, nothing but, for example, we need to select 5 persons committee. We have 7 men and 6 women, right? In that, they given that at least 3 men should be there in the committee. At least 3. At least something minimum. Okay, minimum 3 men. So minimum should be 3 men, or we need to select 5, right? Overall. So at least 3 men or 4 men, or all the 5 members in the committee may be a man. So we have 3 cases. Either case 1 or case 2 or case 3. Is it clear, Akash? Okay. Is it clear? So we need to select 3 out of 5 persons, right? We need to select 5 persons. Out of 5, 3 are men. So 2 will be the women. Remaining 2 will be the women. So 3 and 2 combined, you will get 5, right? Similarly, 4 men and 1 woman, 5 men and 0 women. So these are the 3 cases. Okay. So first case, we need to select 3 men. We have 7 men, right? So out of 7, we need to select 3. And nothing but into. We need to select 2 women out of 6. So we'll get some value, right? 35 into 15. You got some 525. Similarly, you need to select 4 men out of 7 and 1 woman out of 6. So you got same 35 into 6, 210. And you need to select 5 men out of 7 and 0 women out of 6. So 7C5, 7C2 is 21 and 6Z0, NC0 is 1. Okay, so 1. So just add it, you will get 756. So clear? The question is minimum 3 men. Maximum all the 5 persons may be a men. So clear? So we have more cases. So either case 1 or case 2 or 3 or anything but plus. You need to add it. Yes. Any doubts, ma'am? Okay. Okay, we will go to the next one. Shall I clear this page? Okay. Question number 15. So similarly to the previous problem, right? Instead of men, women, we have consonants and vowels. So we have 7 consonants and 4 vowels. Okay. We need to select 3 consonants and 2 vowels. Easy, right? Yes, it does. Good. Yes, ma'am. Either case 1 or case 2. Actually, here also we will multiply it, but some cases we will have actually and, right? Here also we have and. So here also we will multiply it. So we need 3 consonants. So out of 3 Out of 7, we are going to select 3. 7C3. So we are only selecting. In that permutation, if you want to arrange it, okay, if you want to arrange it, you will write like this, right? 7 into 6 into 5. But we are going to select how many words or 3 common vowels can be formed. Okay, so 7C3 under the one into 4C2. Out of 4 words, you need to select 2. So from 7, 3 numbers. So combination, right? So we need to divide by the arrangement. And 4C2. Yes, Sanjuma, good. Yes, Meera. 4C2 by 1 into 2. The 2 3s are 6. Here 2, right? So 35 into 6. The answer is 210. Number of will be very less when compared to permutation. So clear, ba? So we need to select 3 consonants out of 7 as well as 2 vowels out of 4. Just we are selecting. So clear. If you have a word like with or without meaning, how many words can be formed? Then there's nothing but arrangement. If you have a word like how many words can be formed using 7 consonant 4 vowels with or without meaning, then it is a permutation. But here we are going to select, right? We need 3 consonants and 2 vowels. But we have 7 and 4. So out of 7, we are going to select 3. And out of 4, we are going to select 2 vowels. So only selection. It's a combination. Okay, so try the 16th one, similar to the 14th one. Page 175 in material. 16th sum is similar to the 14th one. Give a try. Shall I clear this page, pa? Okay, Siddharth. Okay. So in a group of 6 boys and 4 girls, 4 children are to be selected. So we are going to select 4 children. Yes, essential. Good. We are going to select 4 children. We have 6 boys and 4 girls. 6 boys and 4 girls. Okay. Case, in how many different ways can they be selected? Such that at least one boy should be there. One boy. At least one boy. So we are going to select 4, right? At least one boy must be there. So one boy or 2 or 3 or all the 4 are boys. So clear? So clear, ba? The question is at least one boy, right? At least one boy. So minimum 1, maximum maybe all the 4 may be boys. So if you choose one boy, the remaining must be a girls, right? So 3 girls. 2 boys and 2 girls. You get 4-member committee or 4 children. 3 boys and 1 girl. 4 boys and 0 girl. Okay. So now we need to select 1 boy out of 6 and 3 out of 4. Similarly, 6 out of 2 out of 6. Here also 4C2. Here 6C3, 4C1. You have to select 1 out of 4. Here 4 out of 6 and 0 out of 4. Is it clear, Bang? Is it clear? Okay, 6C1, what is the value? 6C1 is 6, right? And 4C3 is equivalent to 4C1. You add 3 plus 1, you get 4, right? 4C1 is 4. Then 6C2. 6C2 from 6 2 numbers. You will get 15. If you divide, you will get 15. Then 4C2 from 4 2 numbers. You get 6, right? So 24, here 90. Yes, the answer is 209. Yes, 10. Then here 6C3. Okay, you need to find the value of 6C3. So 6 into 5 into 4 by 1 into 2 into 3. So we will get 20, right? Here 20. 4C1 is 4. So 6C4 is equivalent to 6C2. You know 6C2 value is 15, right? So 15 into 1. So finally the answer will end with 9. So 209. Is it clear, ma'am? At least one boy. So minimum one, maximum all the four will be boys. Is it clear? Any doubts? Any doubts? Whatever, any, not any responses? Any doubts, ma'am? Similarly, 17th one is same as 15th. Give a try. 17th one is same as 15th. Give a try. Yes, Sanju. Yes, Siddharth. Good. Four C 2 equal to, from 4, 2 numbers, right? So 4 into 3 divided by 1 into 2. If you cancel it, you will get 6. Is it clear? Okay. Shall I clear this page? Kindly take a screenshot if you want. Yes, Narmada. Good. Yes, Hemant. Perfect. Okay, I'll clear this page. We'll try the next one. So again, 17th, we need to form a committee. Okay. So consisting of 5 men and 6 women. So we're going to form a committee. So 5 men and 6 women can be formed from 8 men and 12 women. Out of 8, we need to select 5 under, right? Under. So into we need to select 6 women out of 10. So 8C5 is equivalent to 8C3, right? Yes, Suresh, good. 8C5 is equal to 8C3. So 10C6 equal to 10C4. You can find the value, right? So 8 into 6 in, sorry, 8 into 7 into 6 by 1 into 2 into 3. You will get 56. 10C4. From 10, 4 numbers, right? 9, 8, 7. 1, 2, 3, 4. 2 4s are 8. 1 time, 3 times. So you will get 210. Yes, Akash, good. So you multiply it, answer will end to 60. So you can check whether you will get 11760. So and definitely answer will end with 0, but 10 into 6, right? 10 into 6, 60. The answer must end with 60. So remaining options are eliminated. You can actually we can make it 11760 or some other number, since we have option E as none of these. So give a try. That's all. Is it clear, Beth? Very easy, right? Okay. Try 18th one. Give a try, Beth. 18th one. Okay, most of them are getting 64. Yes, and choose that. Okay. Okay, I'll clear this page, Beth. So here we have 2 white balls, 3 black balls, and 4 red. 2 white, 3 black, and 4 red. In how many ways can 3 balls be drawn from the box? Actually, you will expect the same question in probability. Okay. In that same method, and finally, you have to divide by sample space. That's all. That's the difference for permutation, combination, and probability. We are finding number of ways, right? We are finding number of ways, and previously, for example, 11760 we got, right? That is permutation combination. If we divide by this overall sample space, then it has become probability. That's the difference here. The same question you can expect there. So 2 white, 3 black, and 4 red. In how many ways can 3 balls be drawn from the box? At least 1 black ball is to be included. Okay, so listen carefully. The condition is for only the black. So we are going to draw 3 balls. We are going to draw 3 balls, right? In that, at least one. At least minimum 1 black ball. So minimum 1 black ball or 2 black ball or 3 maybe a black ball. Since we have 3 black, right? So you can go up to 3. We need to going to choose 3, right? We're going to select 3 balls. At least 1 black ball or 2 or 3 maybe a black balls. So we have case 1, case 2 and case 3 or case 3. So remaining, I can take it as like this, white or red. Okay, white or red. The condition is for at least we have to get 1 black ball, that's all. The remaining may be other colors. So if it is 1 black ball, the remaining 2 must be from white or red. Okay, then 2 are black, the remaining 1 must be a white or red. And 3 are black, then the remaining will be 0. So we have 3 black balls, okay, and white and red. If you add it, you will get total 6. Is it clear, but so from this, is it clear or not? We need at least 1 black ball, right? So 1 black, the remaining 2 must be either white or red. Okay. Similarly, 2 black, remaining 1 must be any other color other than black. Remaining 3 are black. Okay. Here, we need to select 1 black ball out of 3 and 2 balls from other colors. Other colors we have 6, right? 6C2. Similarly, 2 black ball from 3. The remaining 1 will be other colors and 3 from the black and 0 from the others. The condition is for only the black. So 3C1 is 3, 6C2. From 6, 2 numbers. You will get 15. Okay, 3C2 is equivalent to 3C1. Okay, so 6C1 is 6. 3C3 is 1 and 6C0 also 1. If you add, you will get 64. Okay, so NCN also 1, NC not also 1. Is it clear, well? The condition is only for the black. So remaining colors I kept as a 1 single unit. Okay, any color, may white, red, blue, yellow, anything except black, remaining all on one case. Okay, so choose at least 1 ball. So minimum 1 ball, maximum 3 black balls. Since we have 3 black, right? So all the balls may be a black. Is it clear? Any doubts? Okay, kindly respond if you have any doubts. Charan, if you keep the remaining balls separately, you need to find actually we're getting 2, right? Getting 2. So it may be from white or it may be from red. This actually I'm speaking only for this case. Okay, separately, we have many cases. It may be 1 white, 1 red, or both may be a white, or both may be a red. Right? So we have many cases. So in avoiding that, I'm keeping like this. Okay, question is only for black, right? So remaining colors kept as a single terms. If you take separately, definitely you will have many number of cases confused, whether we need to multiply or add it. Okay, for that purpose only, I kept only 2 parameters. One is black, other one is next one is other colors. Which one, Rupa? 6 means 9 minus 3. Which one? Oh, yes, okay. 6 is the thing, but actually red and white mark. Okay. We are considering black ball a separate case. Okay. The other colors are separate, right? Other colors we have red 4, white 2. Total 6. Total 6. Except black, remaining all red and white combined, you get 6 colors. Okay. Is it clear? Shall I move to the next one? Okay. We are moving to the next one. Yes, deep and God 126, 63, 63. Okay. So I think you already done the same question. In how many groups? I mean, how many ways can a group of 5 men and 2 women be made out of 7 men and 3 women? Okay. The option will be, I think, A. Okay, 7 men and 3 women. We need to select 5. 7C5, yes, and 3C2. So 7C5 is equivalent to 7C2, right? 3C2 is equivalent to 3C1. From 7, 2 numbers. Yes, and 63. Good. Most of them got the right answer. Good. Okay. So we will get 21 here. 21 into 3. 63. Yes, Charan. Any doubts, sir? Up to 19th, any doubts? Okay, done. Try the 20th one. Give a try. Okay. A room has 10 doors. In how many ways can a man enter through one door and comes through 2 different doors? Okay. So we have a enter and exit, right? Okay. So we have 10 doors. In which door you will enter? Anyone? In which door you will enter? In which door you will enter? Any one door, right? They didn't give any condition. You have to actually you have to pass through one first door. Okay. The question is, how many ways can a man enter through one door and comes out through different door? So we have 10 doors, right? Out of 10, any one door you can choose. Is it clear? Therefore, 10 ways. 10C1 equal 10 ways. And so into comes out in different door. Suppose if you choose the 7th door to enter, I have to come out of the other doors, right? Other doors. So other doors we have 9. So out of 9, any one door must be my exit. So 9 ways. 10 and 9, 90. Is it clear? Is it clear, but first you need to choose. First you need to choose which door you must enter. Okay. So out of 10 doors, you must choose only one to enter. So out of 10, we have only one door to enter. So 10C1, 10 ways. And for exit, you need to choose different door. So out of 10, I already chose for enter. Remaining, we have 9 doors, right? Out of 9, any one must be my exit. So 9C1, so 9 ways. So if you multiply, you will get total 90 ways. Is it clear, bro? Okay, done. Okay, 21. Give a try. 21. Actually, in our material, some options are mismatched. Huh? Please see the PPT here. Option A and option B. I have changed that. Yes, Siddharth, good. So option A, instead of 1365, write 1001. Similarly, in B, instead of 1235, write 1001. Please correct the options, sir. Okay. In how many ways can a cricket 11 be chosen out of 15 players? This is the question here. In how many ways can a cricket 11 be chosen out of 15 players? Selection, right? Out of 15, we are going to select 11. If there is no condition, you can write like this 15C11. Okay, there is no condition, you can write 15C11 or else is equal to 15C4. Okay, but here they given some condition. First, a particular player is always chosen. Yes, Sanju, good. What is cricket 11? Cricket 11, nothing but we need to select 11 players. Okay, in cricket we have 11 players. Okay, for a game. So we need to choose 11 players out of 15 players. That's the meaning here. Okay, Ruba. So in cricket, there are 11 players. Okay, for each game. We need to select 15. I mean, we need to select 11 out of 15. Okay. If there is no condition, you can write like this 15C11. Okay. Suppose if we have a condition like this, a particular player is always chosen. Always chosen, right? For example, captain is always chosen, right? Particular player is always chosen. So one already over. That's actually one player already chosen, I think, but 1C1. He's already in the game. Okay. Remaining 10 players we need to select out of remaining 10 players we need to select out of 14. Since out of 15 players, one is already selected. Okay, out of 15 players, one is already selected. A particular player is chosen. So out of 15, one is already selected. So remaining we have 14 players. In that, okay, in that we need to select 11 players, right? Out of 11, one is already selected. The remaining 10 must be selected from the 14. So clear? So 14C10. So 1C1 is equal to 1. 14C10 is equivalent to 14C4. Okay. So 14, 4 numbers reverse. 12, 11. 1 into 2 into 3 into 4. So 3 4s are 12. This one is 7. So 91 into 11. You will get 1001. Is it clear, for first case? It's clear or not? One player is always chosen. So instead of 11, now we are going to select only 10 out of 14. Since 15 players, one is already selected. The remaining 14 players, you need to select 10 for the game. Is it clear, ba? Any doubt? So if you have any doubt, please respond to the message. I'm ready to explain once again. Okay. Now, the second case. A particular is never chosen. Okay. Particular for first player is 15C1, right? Okay. No, ma, for the first. Actually, we are asking for a condition 1. You're asking for this condition? No. If you write like the 15C1, this means you can select any one from out of 15. This denotes that you can select any one out of 15. So that means you can select any person. So we have 15 ways, 15 possible ways. But question is not like that. A particular player is always chosen. For example, Dhoni is always chosen. I mean, only one way. There's only one Dhoni is the team, right? So only one way. That's meaning there. 1C1, not 15C1. If we go for 15C1, then becomes any one out of 15. That's the meaning. Okay. Then second case, the particular is never chosen. So out of 15, one person will not be chosen. Never chosen. So remaining we have 14, right? Out of 14, we need to select 11. Initially it was 15 players. The one person will not be chosen always. Okay. Therefore, we subtract it, you will get 14. You need to find 14C11. From 14, you are going to select 11. You can write 14C11 as 14C3. Both the same, right? 14, 13, 12 divided by 1, 2, 3. So 2 3s are 6. Yeah, 6 to the 12, right? 28 into 13, I think it will answer with 4, 3, 6, 4. Option will be B, right? Is it clear about how to find the values? Yes, sir, you can select, we can write 1C not into 14C11. Yes, Meera, you can select right like that. 1C not. So the person will not be selected. Will never be selected. Okay, Velu, want to repeat it again? Both the cases file, only second cases. Okay, I will explain once again for the cases. Listen carefully. Okay, I'll explain both the cases. Okay, so listen carefully here. So we need to select 11 players for cricket. For playing cricket, we need to select 11 players. Initially, we have 15. Okay, initially we have 15. From 15, we need to select 11 players for the game. Okay, so condition 1, they given that a particular player is always chosen. Okay, so out of 15, one player is always chosen. So 1C1. Always he will be there. Okay, and out of 11, already selected 1. Remaining 10 must be selected. Out of 14, since 1 is already included in the team, right? 15 players, we have 15 players. In that, you need to select 11. Okay, out of 11, 1 will be there, always there in the game. So 1 player selected. Only one way for selecting them, selecting him. Okay, only one way. The remaining, we have 14 players. Out of 14, we need to select 10. Okay, so 14C10 is equivalent to 14C4. It is subtracted. So one way, 1, right? So 14 into 13 into 12 into 11 by 1 into 2 into 3 into 4. 4 3s are 12. Here you get 7. So 91 into 11, you will get 1001. Okay, this is the first case. Clear? Second case, a particular is never chosen. So in 15 players, 1 will not be chosen. Okay, we will avoid him. So only we have 14 players now. We never choose one player, right? So I will avoid him. So only we have 14 players. So you need to select 11 out of 14. You will not consider him, right? So you need to select 11 out of remaining 14. So 14C3. So from 14, 3 numbers. By 1 into 2 into 3. 3 2s are 6, right? 6 2s are 12. You multiplied, you will get 14 into 26, 364. Is it clear by now? Velu, Ruba, is it clear? Any doubts, man? Sunny, any doubt after this? Okay, you won't choose one person, so we are avoiding him. The remaining 14, from that 14, you need to select 11. 14C, 11. Okay. If you have any doubt, please respond to message. Okay, Siddharth, good. Give a try. Next one, give a try. Read the question carefully. Give it a try. Please make a copy of this or take a screenshot. We'll move to the next one. Sharon, give it a try. Okay. Shall I clear this page, sir? A selection is to be made for one post of principal and two posts of vice principal. Okay. A selection is to be made for one post of principal and two posts of vice principal. Among the 6 candidates called for the interview, only 2 are eligible for the post of principal, while they all are eligible for the post of vice principal. So, number of possible combination. Okay. So, first is Sanjima. Good. First, who will you select? Principal or vice principal? First, you will select vice principal or principal. Principal, right? Don't go for vice principal. Okay. Suppose if you select for vice principal, actually we have 2 posts for vice principal, right? Out of 6 candidates, you select first vice principal. Suppose we know that there are only 2 eligible candidates for principal. On both the members went for vice principal candidate as a candidate, then principal there will be no candidate, right? Eligible candidates. So for that, just first try to find the principal. So we know that only 2 candidates are eligible for the post of principal. We need 1, right? So first find the principal. So 2C1. Is it clear, but to find the principal, there are only 2 candidates eligible. Out of 2 candidates, only 1 is for the post of principal, right? And we have 2 posts for vice principal, right? But we know that all the 6 candidates are eligible for the vice principal candidate. Okay, so already I have chosen the principal. So remaining we have 5 candidates. Out of 5, we need to select 2. Is it clear? Is it clear, but first we are going to select 1 principal, right? So out of 2 eligible candidates, we are going to select 1. So 2C1. After selecting the principal, the remaining candidates will go for post of vice principal, right? So out of 6, 1 is selected for principal. The remaining 5, we're going to select 2 candidates, 5C2. Okay, the answer is 2C1 is equal to 2, right? 5C2, 5 into 4 divided by 1 into 2. So 2 into 10, 20. There are 20 number of ways to select candidates. The answer is none of the above. Why all of them are getting answer 12? Why is it clear? So we have only 2 eligible candidates for principal. Okay. So we need to select principal first. So 2C1. Out of 2, 1 will be selected, right? So we have 2 ways. They have both of them have chances, right? Therefore, 2 ways. So 1 is selected. So out of 6 candidates, 1 is selected for the principal. Remaining 5 candidates again go for the post of vice principal, right? In that, we need to select 2 persons. Charan should not consider 4C2. Since the person who was eliminated in the principal round will again apply for the vice principal, right? We have 6 candidates totally. Okay, we have 6 candidates, but in that 2 are eligible for the principal post. That's all. They all came for interview, right? 1 post principal, 2 post vice principal. They all came for interview. In that, only 2 are eligible for the principal. So chances of getting a post principal is only 2 ways, only 2 persons, right? So 1 will be selected as a principal. The remaining 5 will be selected as a chances for vice principal. So 5C2. Is it clear, Charan? Okay, good. Okay, so all are candidates for interview. So if I If one person, actually they select for principal as well as for vice principal. One is selected, remaining 5 will be chances for vice principal. Is it clear? Can you try the last one? So read the question carefully and give a try. Give a try. So getting 7. Okay. Okay. So we move to the next one. A student has to opt for 2 subjects. A student has to opt for 2 subjects out of 5. A student has to opt for 2 subjects out of 5, right? They have commerce, economics, statistics, M1, M2. M2 can be offered only if M1 is also opted. They're given some conditions, right? M2 is offered only if M1 is offered. Opted. Yes. Yes, ma. Yes, Meera. Good. Sorry, Meera, give a try, ma. The number of different combinations of 2 subjects which can be opted as. Okay. Who is willing to explain? Anju or Siddharth? Who is interested? You need to select 2 subjects, okay? M2 will be offered only if M1 is opted. Now, who is interested for Anju or Siddharth? Who is going to explain? Anyone? You are willing to explain this? No, it's not 5. Okay, suppose you go for case 1. Okay, it is a case 1. If I opt M1, okay, or else we go for case 1 like M1 is not opted. M1 is not opted. This is a case 1, okay. M1 is not opted. Then 2 subjects out of 4 must be chosen, right? Yes, Suresh, good. M1 is not opted means, okay, then out of 4 subjects, 2 must be selected. Is it clear or not? Okay, anyone going to explain this question? Suresh, can you explain this? Siddharth, can you explain this? Shall I make you unmute? Give a try. Maybe whatever answers, give a try. Yes, Siddharth.
Yes, sir. I initially took instead of taking 5 subjects, I took the 4 subject. I rejected the max 2.
Okay.
So we have to select 2 subjects from that 4 subjects. So it's 4C2.
Good.
4C2 equals 4 into 3 by 2 equal to 6.
Okay. Then.
Then the next case is choosing max 2. When we choose max 2, the first subject has to be max 1.
Okay, good.
So that will be one case. So 6 plus 1 equal to 7.
Perfect. Good. Okay. Good, Siddharth. Thank you. Okay, see here I mentioned M1, right? Actually, it's M2. The conditions were only M2, right? Okay. The first case I went for M2 is not opted. M2 is not opted. Second case is M2 is opted. Okay. Listen carefully. If M2 is not opted, then out of 4 subjects, any 2 can be chosen, right? M2 is not opted. But actually, we have two cases. One is they given that M2 can be offered only if M1 is opted. So I'm taking M2 is not opted. Okay. Second case, M2 is opted. If M2 is not opted, then out of remaining 4 subjects, I can choose any 2. So 4C2. So clear? Then second case, M2 is opted. If M2 is opted, only if M1 is opted. So only if M2 is opted, then only one possible way, right? M1 must be opted, only one way. Therefore, for this case, only one way. For this case, we have 6 ways. So total either case 1 or case 2, right? So total equal to 7 ways. Is it clear? Either case 1 or case 2. If case 1 is M2 is not opted. Okay, if M2 is not opted, then remaining 4 subjects can choose any 2. So 4C2. Okay, if you want to choose M2, then M1 must be opted previously, right? So only one way. M1 must be opted before choosing M2. Is it clear, bro? So only one way. So for this case, what overall will be 7 ways. Is it clear for everyone? Is it clear? Yes. What's the doubt, man? Yes, Aishu, what's the doubt? If M2 is not opted, then total subjects will not be become 4. Actually, condition is if you want M2, you must select M1. They didn't mention that if you select M1, you must select M2. They didn't given the points like that, right? If you select M1, then definitely you should select M2. It's not given. The condition is if you select M2, then M1 will be the one-off subject. Okay, so clear. So the main point is here M2 is opted or not opted. That's the case. Yes, ma'am. Was it clear? Any doubts in today's session? Any doubts in today's session, ma'am? Okay. I'll recall some of the concepts of today's class. Okay. Is that? Yes, this will be the maximum level for you. Okay, this is the maximum level. Okay. Okay, so in how many ways the shirt, how many number of ways a word shirt can be arranged? In how many number of ways a shirt can be arranged? Actually, Ruba, they have mixed the question in the inside 23. Actually, while taking probability, you have same concept. You must know the concepts of permutation combination before completing the class probability. Okay, you must know the permutation combination topic. In that, we have UPSC questions. Okay, how many number of ways a word can be arranged? Shirt. How many number of ways can be arranged? So 1, 2, 3, 4, 5, right? The answer is 5 factorial, or you can say that 120. Okay, it's clear. Okay, in how many 3-digit numbers can be formed using the digits 890? How many 3-digit numbers can be formed? How many 3-digit numbers can be formed by using 890? Okay, so 3-digit numbers, right? The first place, what are the cases, bro? First place, what are the cases? Out of 890, what are numbers are possible? Only 8 and 9, right? Only 2 ways. The second place, suppose say 9 is replaced here. In the second place, 0 may occur, right? So again, we have 2 ways. The last place only 1 way. So clear? So total 4 ways, not 3 factorial. If you say 3 factorial, then 0 may be in any number, any place. Maybe 0 may be here. So clear? So this case will be omitted. Actually, to arrange three numbers, we have 3 factorial, right? To arrange three numbers, 3 factorial ways. Nothing but 6 ways. In that, you can avoid the 0 as a first digit. You need to get a 3-digit number. So these two cases will be eliminated. Then you will get 4 ways overall. Is it clear? Nothing but you can get 890 or 809, 908 or 980. These are the only 4 ways you can arrange by using the numbers 890. Is it clear? Is it clear, Bal? Is it clear or not? Okay. Kindly arrange a word Mississippi. Kindly arrange the word Mississippi. Anyone? Ruba, Esma? What are the number of ways you can arrange the word Mississippi? So first count the number of letters. Okay. So 1, 2, 3, 4. Yes, Meera. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So 11 factorial. Divide by, we go for M. So only one M. So leave it. We go for I. 1, 2, 3, 4. 4 I's are there, right? For S, again we have 4. Then P. Is it clear? Yes, good. Can you try for aptitude? Can you try for aptitude? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, right? 8 factorial divided by P 2 times. Is it clear? 8 factorial by 2 factorial. For same question aptitude, find number of ways to arrange aptitude in that such a case, vowels always together. For aptitude, how many number of ways you can arrange a word without meaning? Condition vowels always together. Vowels always together. Vowels always together. Okay, so here we have vowels A, I, U, E. Right? Remaining we have P, T, T, and D. Okay, so count it. So 1, 2, 3, 4, and 5. So 5 factorial. But in that T is repeated 2 times, right? 5 factorial by 2 factorial. Into here we have 4 letters, right? So 4 letters to arrange 4 letters, we have 4 factorial. So this is the answer. So clear, but okay. Now, next question is fridge. Okay. The question, listen carefully. How many number of ways a word fridge can be arranged such a way that vowels occupy only the odd places? Vowels occupy only the odd places. Now, what is the value here? Vowels occupy only the odd places. So fridge we have 6 places, right? 3, 4, 5, 6. Vowels occupy only the odd places, right? So right here, the number of first place, second place, third place, fourth place, fifth place, sixth place. The vowels occupy only the odd places. So we have 2 vowels here. Vowels occupy only the odd places. How many odd places are there? How many odd places are there? 3, right? 1, 3, 5. Okay. Out of 3 places, the vowels are going to occupy only the 2 places, right? We have only 2 vowels. Out of 3, we are going to occupy only the. So 3P2. This is the first point. Vowels occupy only the odd places, right? We have 2 vowels, but here we have 3 odd places. So out of 3 odd places, 2 are going to be filled. So 3P2. Okay. Then, so 2 will be filled, right? Remaining how many letters are there? Remaining. So 2 vowels will be placed in the place of 3. Out of 3, 2 will be filled, right? Remaining we have 4 letters and 4 places. 4 letters and 4 places. Therefore, answer must be 3P2 into 4 factorial. Is it clear? 3P2 into 4 factorial. Is it clear? Okay. The word fridge, the vowels occupy only the odd places. So we have 6 places, right? In the out of 6 places, we have only 2 vowels. So just if you have 1, 3, 5, must occupy only the odd. So out of 3, only 2 letters going to occupy the places, right? So 2 will be occupied in any of the 3 places. After that, 2 places are filled, remaining 4 places, 4 letters. So 3P2 into 4 factorial. The answer will be some 144, I think. Yes, 144 then. Was it clear how to place a odd place and even places? Okay, give a try. Similarly for aptitude, give a try. The vowels must always occupy the even places. Give a try for this question. Vowels occupy only the even places. For aptitude. What is the answer for that? Vowels occupy only the even places. So just draw 8 lines. Okay, so here we have vowels A, I, U, E. How many even places are there? How many even places are there? 4 even places, right? So 4 even places, 4 letters. So 4 places, 4 letters. Nothing but answer is 4 factorial. Is it clear? Nothing but 4P4, right? Is it clear? So 4 even places, 4 vowels. So 4 places, 4 letters, 4 factorial. Remaining again we have 4 letters and 4 places. So what is the answer again? 4 factorial. But in that we have P 2 times. Don't forget that. Okay. By 2 factorial. Since we have remaining PTTD, right? So remaining 4 letters, 4 places. But T is similar 2 times. So 4 factorial by 2 factorial. Is it clear how to find this? Is it clear, Bang? Any doubt? Okay, some answer maybe 5, 7, or something like that. Okay, ma'am. Is it clear? Any doubts? Okay. Now, the next concept. Shall I clear this page? So clear this page. So now the word places. Okay. Here the question is, no two vowels are together. No two vowels are together. What is the answer here? No two vowels are together. How many ways a word places can be arranged such that no two vowels are together? No two vowels are together. What is the answer here? Anyone? Some of them leaving the classes, okay, but learn the concepts. Huh? Okay, so we have two vowels, right? Okay, so first, no two vowels are together. So write the remaining letters first. P, L, C, S. So you can arrange the vowel in the interval, right? In the gap. No two vowels are together, right? So first I am arranging the word P, L, C, S. To arrange the word 4 letters, we have 4 factorial. Okay. And now the vowels must be placed in between them. So we have 1, 2, 3, 4, 5. But we have only 2 vowels. So out of 5 places, we are going to place 2 vowels. So 5P, 2. This is the answer. So 24 into 5 into 4, right? 5P2 is 5 into 4. So 480. Is it clear? It's clear or not, man? Yes, actually, you can do like this, or else you remember the condition. There is no condition. We have 6 letters, right? 1, 2, 3, 4, 5, 6. To arrange 6 letters, 6 factorial, which is 720 ways. There is no condition. Okay. Okay. As this is another method, listen carefully. Yes, sorry. Method 1. Okay. This is, there is no condition. Okay. There is no condition. You can arrange a 6-letter word as 6 factorial. Next condition is vowels always together. Vowels always together. Then you can write like this, right? P, L, S, C, S, then A, E here. In that case, 1, 2, 3, 4. This one is 5. So 5 factorial into this 2 factorial. So you will get 240. Okay. The vowels never together. Never together means you can subtract overall number of ways minus this vowels together. If you subtract these two, you will get the vowels never together, right? You can write like this 480. Is it clear? You remember that concept? Okay. So first one is 6 factorial is nothing but any number of ways, total number of ways. You can write, you can rearrange arrange the letters in any order. So you have totally 720 ways. In that, if you subtract vowels together, you will get vowels never together. Is it clear? Okay. So like that, Rupa, this one is actually second method. Actually, I explained this previously, right? This one. This one is method 2. Should I take method as 2? Okay. This one method 1. So we have first we need to know two words are together. So for that, first replace a consonant. I am arranging the consonants. Yeah, we have P, L, C, S, 4 consonants. To arrange 4 letters, 4 factorial. Then no two words together, right? So I am placing a mark here. If you fill A and E here, then this will be A, P, E, L, C, S. Or if you place A and E here, for example, you will get P, L, A, C, E, S. Like that. We have many options, right? So we have interval 5 gaps between the letters, consonants. We have 5 gaps. So first I arranged the consonants. So between the consonants, we have 5 intervals. So in that, any 2 places will be occupied by A and E. Okay, therefore 5P2. We have only 2 vowels. Okay, we have 5 interval gap, right? Out of 5 gaps, any 2 will be occupied by AE. Okay, then no 2 vowels will be together. So 5P2 is 20. 24 and 20, you will get 480. Is it clear? Any doubts, sir? Any doubts? Any doubts in today's class? Last one more thing. Do you remember how many 3 different digit numbers are there between 100 to 200? How many 3 different digit numbers are there? How many 3 different digits are between 100 to 200? Sounded to write. Do you remember that? My question is here, from 4,300 to 5,000, how many 4 different digits are there? From 4,000 to 5,000, how many 4 different digits are there? Between 4,300 to 5,000, okay, how many 4 different digits are there? So just mark the 4 places, fill it up. Okay, I will clear this page. So between 4,300 to 5,000, how many 4 different digits? How many 4 different digits? So 4 places. We have digits 0 to 9. Okay, how will you find this? So what is the first number here? Which number will occupy this place? Yes, Hemant, we will check that. No, Charan. Actually, the question starts from 4,300 to 5,000, right? The first place filled only by the 4, not 5. If you apply 5 here, we have 3 more digits. If you fill, definitely it will be more than 5,000, right? So only one option is 4. So only one option is 4. Only one way. Only one way. 4 will be occupied in the first place. So clear? 4 is occupied. Different digits, right? So not repetition not allowed. Second place, what is the case? This is the important case here. What is the second place? What is the number I can occupy in the second place? What are the numbers? The question starts from 4,300. The question starts from 4,300. So second place will be occupied by, okay, second place is occupied by either 3 or 5, 6, 7, 8 or 9. Since we can have like this, right? 4,301. This is the first value. For all the 4 digits are different. We can have 502 or 140. So you cannot have 4, right? Already if your 4 is applied. So 5, 6, okay, 7, like that, right? 8, sorry, 5, 4, 9, 0, 6, something like that. Okay. So except 0, 1, 2. Except 0, 1, 2 in the second place, can have other numbers. So you can have 3, 5, 6, 7, 8, 9. Since the number starts from 4,300. Okay. So we are avoiding zeros, 41, 42 series. We are starting from the 3 series. Okay. So 0, 1, 2 is avoided. So remaining we have 1, 2, 3, 4, 5, 6. So 6 ways. Out of 6, any one will occur. Any one. For example, if I take 7 here. Okay, 7 here. Now, in this place, how many numbers are possible? In this case, how many numbers are possible? Already 4 out, 7 out. Now we can have 0, right? since first number is 4301. Is it clear? So now in this place we can have 0. So except that these two terms, remaining 8 have chances and 7. That's all. So final value will be 1 into 6 into 8 into 7. So 48 into 7. What is the value? 336 numbers. So clear? Out of 700, 336, 4 different values will be there. We need a second digit is important for second place. To fill the second place is very important here. Okay. So for permutation, selection and arrangement, order is most important. Okay. But in combination, only selection. Order is not necessary. Is it clear? Pa? Any doubt up to this? Any doubts? Yes, Namadam. Okay. Namadam, can you please wait for 1 minute? Okay, but if you have any doubt, please stay back, or else you can have a break. We'll meet once again next week. Okay. Thank you. Narmada, actually, second place, sixth place, nothing but the question starts from 4,300, right? Yes, thank you, ma'am. Thank you for all. Narmada, ma'am, the question starts from 4,300, right? So definitely second place starts from 3 or 4,400 or 4,500 or 4,600, like that. Right? So correct. Second place number starts from 4,300, right? So 4,300 means maybe next series will be 4,400 something. Next series 4,500, 600, 700, 800 and 900. Therefore 0, 1, 2 is not possible. 0, 1, 2 is not possible. Similarly, first place was occupied by 4 already. First place was occupied already by 4. So already one number out, here 3 numbers out. Total 10 digits. From 0 to 10, we have 10 digits. In that 10 digits, 4 is already occupied the first place. 0, 1, 2 is not possible in the second place, since the number starts from 300. Okay. Therefore, the remaining numbers are 3, 5, 6, 7, 8, 9. Only 6 possible values. Out of 6, anyone will come in this place. Is it clear, Namada? Good. Okay, ma'am. Okay, thank you, thank you. Any other doubts, ma'am? Any other doubts? If you have any doubts, please respond to the message or raise a hand. I will explain once again. So clear now? Okay. Then thank you all. Once again, we'll see you in the next class. Thank you. Thank you all.